Is we have three invited talks in this session. First of all, I would like to thank you all for being with us today. My name is Dalmini Shad and I will co-chair this session with session manager Mr. Muhammad Umair Wahid and session chair Dr. Ghulam Abbas. Thank you Dr. Ghulam Abbas for joining us. Let me introduce you Dr. Ghulam Abbas, who is also the first speaker of this session. Dr. Ghulam Abbas received his bachelor's degree in electrical engineering from the University of Engineering and Technology Lahore in 2004 and master's and PhD degrees in electrical engineering from Institut National des Sciences Appliquées de Lyon, France in 2008 and 2012 respectively. He is currently working as a professor in the Department of Electrical Engineering, University of Lahore, Pakistan. He has published a number of papers in various national and international IEEE conferences and journals of repute like IEEE, Elsewhere, and MDPI. He is a reviewer of several premier conferences and journals, including IEEE Transactions on Industrial Informatics, Asian Journal of Control, Engineering Optimization, IEEE ICECE, and many more. He has served several electrical and computer engineering journals as a guest editor. His research interests include analog and digital controller designs for power switching converters, soft computing, solar photovoltaic systems, renewable energy systems, and power system optimization. Dr. Ghulam Abbas will give talk on achieving economical power system operation by optimization technique. Please welcome Dr. Ghulam Abbas with a huge round of applause.
Bismillahirrahmanirrahim. I am Dr. Ghulam Abbas. Currently, I am working as a professor in the Department of Electrical Engineering, the University of Lahore. I am also a session chair of this track, Energy and Economics, and also a keynote speaker to speak about achieving economical power system operation by optimization techniques. So here is the presentation outline. First of all, I think that yeah. Okay. Here is the presentation outline. First of all, the introduction of the economic dispatch problems, then the formulation of the dispatch problems will be discussed, then calculus-based algorithms named interior point algorithm will be discussed, then three scenarios of economic dispatch problems and their solutions will be discussed. Then I will talk
Recording in
about
progress.
recently introduced dispatch problems and what are the various optimization techniques that are being utilized to solve economic dispatch problems. Then at the end, conclusions will be drawn. Okay. So why we need to study the economical power system operation control? The reason is that we want to fulfill the demands of load while keeping the cost minimum, and at the same time we have to fulfill the constraints which are in the form of equalities and inequalities. So definitely we want to save money, and at the same time we want to fulfill the demands of the load, and that can be accomplished with optimization techniques. If you have a lower number of units, then you can do it even manually. But with this increase in size of units in a power system, then definitely you have to find optimal combination of each power generating units so that the load demand can be fulfilled, but at the same time you have to keep the cost minimum. And at the same time, you have also fulfill or meet the constraints which are in the form of equalities and inequalities. So efficient and optimum economic operation and planning of electrical power generation systems have always been occupied. And periodic changes in the basic fuel prices, so we have to keep in that mind, and definitely we have to reschedule our units so that we can get power but with minimum cost. Inflation problems, and definitely when inflation is there, then you want to save the cost of your fuel, and in order to, but at the same time you want to meet the load demand, so you have to find the optimal combination of each power generating unit's cost. This actually transforms into economic load dispatch problems, and to reduce the total fuel cost, fuel prices are increasing daily. Optimum output power from each generating unit needs to be achieved. So we will discuss the optimization techniques in this talk. How can we find the optimal combination of each generating unit's contribution to meet our load demand? So so how can we define economic dispatch problems? So economic dispatch problems is to determine the best power output combination across all generating units in order to reduce overall fuel cost while fulfilling the total demand, keeping in view the constraints, equalities and inequalities. So when we talk about optimization techniques, then problems, then we need to have a cost function, we need to have constraints, and then you formulate your problem, and then you solve it to come with a solution. So economic load dispatch problems, actually it is about the reduction of the power generation cost, and it is about satisfying the equality constraints, power demand, satisfying inequality constraints. We will see it. Okay, I start with a simple thermal unit, and then I will add other resources into the problems. And then we will keep on solving this economic dispatch problem with the help of the optimization techniques. So first of all, you should know about the relationship between the input and output. Here, our input is megawatt that we are going to achieve power, and as a result of this, we have to bear the cost. So along y-axis, you can see that we have cost, fuel cost, dollars per hour, and along x-axis we have power. And there is a P-min and P-max. So this is actually the very first inequalities that when you want to operate a unit, so you have to get this unit needs P-min and P-max. So there are three scenarios. We have quadratic function, the rightmost Here, this is just a quadratic function between the input power and the fuel cost. But sometimes you have to, you need to have more power, and for this purpose, you have to open multiple valves. So when we open multiple valves. So in order to model it, we add ripples or sinusoidal waveform over the quadratic function. So this depicts the opening of the valves, and this requires when your load demand actually increases. So mathematically speaking, it will add some nonlinear term with function, and it makes the problems a bit complicated and complex. Right, and the third one is a cubic cost function, and this is the relationship. So your input megawatts and the output fuel cost, they are related by these relations. We majorly concentrate on the quadratic and quadratic function with the wall point effects. Okay, next slide, please. So the scenario one, in this scenario, we just okay. इस तस्वीर में
जी ठीक
ठीक है
जी ठीक है
पैटर्न ये वो है ठीक okay. So the first scenario, this is the simplest one, and in this scenario we will take only the thermal generating units. Please, next slide, please. Okay, so as I have already told you that the economic dispatch problem is essentially an optimization problem, and for optimization problems you need to have some cost function. So the very first equation, Ft, min of Ft, that is the sum of all the cost from all generating units, and here Fipi, that is the fuel cost, that is a, and it may be in terms of quadratic with wall point loading effects, and the third one is the cubic, as I have already remarked. So this is the cost function. So cost function is the sum of all the cost offered by each generating unit. Okay. Then we have to find the minimum of this cost function, but at the same time, the first constraint, that is active power balance equation, that is the sum of all the generating powers, sum of all the generating power should be equal to the load demand. So right hand side P load, if this equation is valid when the losses are considered, but if you consider the transmission losses, then total generation will be equal to the load plus the losses. The loss of generated power, and this formula is given by Cron, and P loss can be calculated by this. So this is the very first constraint, that the total generation of your power should be equal to the total load demand, whether you have considered losses or not. The second one is PI. Each generating units must work within its Pmin and Pmax. Another generating ramp rate limits. We don't want our generating units to step up or step down the power exponentially. We want the generator should increase its power or decrease its power in a linear way. So in order to incorporate this, we also introduce ramp rate limits. That is also another constraints. The fourth one constraint is prohibited zones, and you can see in the right hand side that there are some zones where we want that our generating units should not work. Okay, so you should also keep into mind, maybe due to the bearing or something else, you want not to operate your generating unit within that particular region. So these are the constraints you have to fulfill. The very first, so your problem has been formulated. Now it's time to define or select your algorithm. So I have selected advanced calculus based algorithm, that is the interior point algorithm. This takes the original problems, then this adds S variable, that is the slack variable. So original problem is got converted into the approximate problems. Then we add a barrier function into it. This becomes a Lagrangian, and then we applied the k-key conditions on it, solve these four equations, and ultimately we come with x k plus 1, mean to say that the next iteration's value is equal to the previous one plus some constant alpha s plus delta x. So actually problem is that you have a cost function, so you take smaller steps and ultimately you come to the solution which gives you the minimum. So interior point works just like that. Unfortunately, I have less time, so I have to pass on. So this is the algorithm, and we have also published a paper on it as well. Now we discuss a 10-unit system that is available in, we have taken this data from the literature. So this is a 10-unit system, and Pmax has been given alpha A, B, and C. These are the cost coefficients, and this is the data. And then we have applied that in interior point algorithms, and you can see that total demand was 616 megawatts. And from the literature, PSO, then MIWPSO, particular swarm optimization, then directional BAT algorithm, Bell algorithm, genetic algorithm, and the right hand side is the interior point that we have applied. So it gives you all the algorithms give you the power contribution from each unit, and the sum of this will be equal to the 606 megawatts. And you can see interior point algorithm gives a lower cost, that is 95,632.12. So these are the cost dollars per hour. Just that why this is the advanced calculus based technique. Usually your advanced calculus techniques, algorithms, they trap into the local minima, but for less constrained problems, even your numerical or advanced calculus algorithms works very well. And they are as competitive as the meta heuristics. When your problem is quite simplest. Here we have just considered one equality, and that was the total generation will be equal to the load demand. And one inequality, that was actually the your P should be within its minimum and maximum value. So the finding of this is that interior point algorithm, that is a local optimizer, even can perform as better as the meta heuristics subject to the your problem is is less constrained. Then this is the curve, and the first one is the contribution of each generating units. The second one is the function value, that is the cost value. And you can see with the progress of the iterations, your total cost minimizes. The third one is the first order optimality. It gives you the indication how two readings are quite close to each other. Then we have taken a 40 unit system. In a power plant, we have 40 thermal units, and the data is given to you, ABC, and here we have introduced the wall point loading effects. So the problems become a bit complicated. Again, that algorithm has been applied, and it gives as competitive performance as rather a bit low compared to the other meta heuristics interior point method. And the reason is that even if 40 generating units were there, but since the problem was less constrained, so ultimately this interior point method has gave the overall total cost quite close or less compared to the other meta heuristics. So 40 unit systems, okay? Then this is the graph. The first one is the contribution of each generating utility. The second one gives you the function value, and it becomes stable. And you can see from the table and from the graph as well that it gives you $122,265 per hour. Scenario 2, no, we make the problems a bit complicated, and combined economic problems here, not only the cost function but also the emission function will also be minimized. So this is a multi-objective optimization problems, and you have to reformulate your problems. So the total cost will be the sum of your fuel cost plus PF, here is the penalty factor, and EIPI, the sum of all this is the emissions. So FP is a function, quadratic function, but with wall point loading facts, and then EIP is the emission. That is also depends upon the power, okay? So if you get more power, definitely you have to burn more coal, and ultimately more tons of coal has to be burnt out to get. So we want to reduce this. So penalty factor is being calculated by the formula here, FIPI, max scenario we set, and constraints we have considered, the total generation will be equal to the load. So by adding these two, we have converted the multi-objective problem into a single objective problem, and then we will apply the optimization techniques that we have already. So this is the data. The first table gives you the cost coefficients. The second table gives you the emission coefficients. And here are the results. 10 units were there. Total demand was 2,000 megawatt, and fuel cost was 1.11 into 10 raised to the power, and at the same time, emission cost was this. So even if we can solve multi-objective problems with the help of interior point methods. Scenario 3. So with the passage of time, we actually want to avoid thermal generating. So now we are introducing renewables into it as well, to make the energy clean. But still, renewables are not as famous as should be in Pakistan. So here, this third scenario actually is the combination of the thermal units along with the integration of the renewables. So this is a scenario, and here the total cost will be due to the thermal plus WPW, that is the fuel cost due to the wind, and plus fuel cost due to the sun. So cost function of all these have been given, and you have to sum up all these to make your overall cost, and then you need to optimize this functions. The lower two equations give you the power generated due to the wind and power generated due to the solar. Okay, so it is the combination of three functions and renewables. So we have used various meta-heuristics algorithms, and it is become quite complicated for the interior point method to solve such kind of problems where more and more functions are involved. Left-hand side, that is the flowchart of a genetic algorithm. Yeah, remember that genetic algorithm involves three operators, that is a selection, mutation, and crossover. So initially it was quite good, but compared to the other meta-heuristic algorithms, it does not perform as efficient as the others. So the right-hand side is a particular swarm optimization's flowchart, and it uses the velocity and positions of the particles. Randomness is there, and this is also used to solve economic dispatch problems. There is a BAT algorithm, and BAT algorithm is the more rigorous algorithm compared to the genetic algorithm and particular swarm optimization, because it involves not only the position or velocity of the bats, but also the loudness, pulse rate, and frequency of the voice it emits. Then we have proposed a directional BAT algorithm. We have and there is a big difference between the BAT algorithm and directional BAT algorithm. There is a difference in initialization of the bats. Each bat represents an optimal solution. So you can discuss. So for these problems, we have taken 7 units. These are the thermal coefficients, and along with the Pmin and Pmax. This problem is dynamic. Here we have not taken the one load demand, rather we have taken 24-hour load demand. Okay, so we have 24 hours load demand, and we want to actually fulfill these demands. Definitely for 1 hour, the combination will be somewhat else. For the next hour, definitely generating units have to reschedule themselves to fulfill the demands. The lower curve is just the load demand, and from where we have taken 24 values. So when we here, unfortunately, I could not mean to say. So left-hand side, we have in. So this is a load demand that you need to actually fulfill, and it is a 24-hour load demand, and the lower curve gives you the demand continuously. So this is a dynamic economic dispatch problem, as I have already remarked, because here you have to fulfill the 24 hours demand, and each generating unit has to reschedule itself to fulfill the demand. Remember that the total generation should be equal to the load demand. Here we have 24 values of the load, and definitely we have 24 different combinations of the power generating units. So unfortunately, because there was a 24 and 7 generating units, so we have used BAT algorithm and directional BAT algorithms and to fulfill the demands. And here you can see directional BAT algorithms, due to its distinguished features, gives a bit low total cost compared to the others. We have introduced renewables. We have taken one solar unit as well as one wind, and 7 thermal units. So with renewables, not only we have reduced the cost, but also definitely clean energy has also been achieved. So this is a pictorial description. You can see with renewables red, and without renewables, we are mean to say saving less cost is being offered by optimization problems having renewables, but at the same time you also get a clean energy. The first graph is BAT algorithm, and the second one is the directional BAT algorithms. So this is actually the cost offered by the BAT algorithm and directional BAT algorithm for renewables and without renewable cases. This is the convergence curve. How does your algorithm works? First, initially we have mean to say higher cost, then with the iteration, with the progression of the algorithms, new value of the cost function is calculated, it is compared with the previous one, and if it gets lower, then it will be updated, otherwise the previous value remains the same. Ultimately, you can see that with the iterations, you get the low cost, so your cost function converges to a specific value, and that is the minimum value that we want to achieve. For 1800 megawatt load, we have compared these systems, static algorithm, particle swarm, BAT algorithm, and DVA. And first, thermal units cost, you can see that DBA, BA gives you rightmost columns less cost compared to the genetic algorithm. Genetic algorithm involves selection, mutation, and then crossover, and it involves coding, decoding. It takes more simulation times. Although it is a meta-heuristics, sometimes give good results, but with the advancement of the new meta-heuristics, other meta-heuristics surmounts the performance of the genetic algorithms. So the second table here, again, 4 algorithms have been compared, but we have taken the wind and solar also into account. And ultimately, you can see that directional BAT algorithm gives you 22,899.4 dollars per hour cost, which is less compared to the other algorithms. These are the convergence curves of all the 4 algorithms, and you can see the first one is the genetic algorithms, the green one. The remaining 3 algorithms, they are recently developed, and they are giving, they offer better convergence characteristics curves compared to the genetic algorithms. Remember that all these algorithms involves randomizations, and this gives us an advantage that the algorithms will not converge to a local minima. Diversity is there, and ultimately it will always gives you the global minima compared to the simple advanced calculus based techniques, which may become trapped to some local points. So these are the convergence curves, that actually the cost curve with respect to the iterations. So we have seen 3 scenarios. We have started with the simple generating unit systems, then we have introduced another term corresponding to the mission, and then we have introduced the renewables in the thermal units, and the objective is to fulfill the demand of the load while keeping the constraints in the form of equalities and inequalities. People are working, and recent areas, this is the summary. Large-scale economic dispatch problems, there are sometimes we have 140, 180, 160 thermal units. So such kind of problems also exist. Combined economic and emission, we have discussed combined heat and power dispatch. This also problems exist, and here you can see that tri-generation concept is there, efficiency increases in this particular concept. Then multi-area economic dispatch problems. If one area could not fulfill the demand of the load, so how can we get power from the other areas through tie line constraints? So this is another, if you want to do work, if you want to do research. So these economic dispatch problems, they are recently, and researchers are working on in that. Then economic dispatch in microgrids with renewable energy sources, wind, solar, biomass. even hydrothermal, they are all integrated into the one. And because these are the various sources, constraints will be different. So to handle such kind of problems are a bit tricky, and definitely you have to use rigorous matter restricts techniques to accomplish these tasks. Then electric vehicles plugged in economic dispatch problems. So electric vehicles, when they get a charge, they are acting as a load. When they are getting discharged, they are giving power back. So they can also be plugged with the other, and then you have to find the optimal combination to give better solution. Economic dispatch of hydrothermal power systems. So hydro and thermal, they also get together, and definitely, like in country Pakistan, we can't fulfill the demands of loads solely from hydro units. So we have to combine thermal and hydro to fulfill the demands. So this becomes another economic dispatch problems. So these are recently developed and researched economic dispatch problems. I have just given you the summary. 3 different scenarios we have discussed, but it is hard to discuss all these. Then this is a summary of the optimization techniques. They are numerical methods. They are advanced calculus-based methods. When your constraints are reduced less, when your optimization problem is less constrained, then you can use these calculus-based techniques. So Lagrangian multiplier, lambda iteration method, base points, to Maclaurin series approximation. These are all the local optimizers. So local optimizer means that they try to minimize the cost of function. As soon as the first peak, lower peak minima occurs, they may get trapped into it. So if your economic dispatch problem is quite simple, then you can use these algorithms. But if it is heavily constrained, a lot of equalities and inequalities are there, then definitely they are not recommended. So people have introduced these various optimization techniques. These are meta heuristics. All these techniques involve randomization in their equations. And as a result of this, they don't trap into the local minima. Rather, they give you the global minima, and that is our requirement. So the working principle of all these meta heuristics people have introduced, and still a lot of meta heuristics are being introduced and developed. So this is a list of all meta heuristics that are being used to solve optimization problems, economic dispatch problems. Sometimes people also use a hybridization of these 2 algorithms. The meta heuristics may be coupled with your numerical methods, and here one of the algorithms works very well for local search, and the other one works very well for the global search, and we use the salient features of these 2 algorithms to solve our problems, and ultimately we want to so this is the list. This is still going on, and people study the natural behavior of something, and on the basis of them, they develop the equations and give you the meta heuristics. But I have already remarked that all these methods involve randomizations. So initial populations, they are all the particles are unusual, they are far from each other, and then so conclusion, we have computer-based numerical methods used for constraint optimization problems. Shows evidence that our numerical methods may be competitive as the meta heuristics, as far as your economic dispatch problems are less constrained. Then we have proposed a solution to combined economic emission dispatch problems. Medium scale to large scale economic dispatch problems have also been considered. Using renewables creates obvious impact on economics of the systems. For dispatch problems with renewables, we have compared PSO, GA, BA, and directional bat algorithms, and we have seen that DBA overshines the performance of the others. A summary of recently developed suggested dispatch problems has also been presented. If you want to work on that, then you can select one of them and apply meta heuristics or derived version of the meta heuristics to ensure reduced cost while fulfilling the load demand. Optimization techniques list I have also provided that are being used, and hybrid forms of them also are being used. You can develop your own algorithms by mimicking some natural phenomena, and ultimately trends for future dispatch problems and their solutions have been also highlighted. So this is all about my presentation, and if you have any question, please ask.
It was very well presented, Dr. Talk. I couldn't attend the whole talk, but I just have a few questions. You have listed several economic dispatch scenarios, and included the renewable as well. And then have you considered the dispatch together with the cost of transport, since economic dispatch could result into transportation of energy? For example, the load is at certain location and most economic dispatch is at a far distance. Then ultimately energy cost may increase because of the transportation that is getting involved. Yes, I see that. And your intelligent techniques, you mentioned several of them. I'm sorry I came very late, but I saw a lot of techniques which are heuristics, which are probabilistic based mathematical optimization, and then you come to the intelligent part, and where you listed artificial neural networks, and you have also mentioned GA. There are many at this time advances in AI. So a lot of the work that is done.
You have to define a lot of hidden areas, and if your problem will become more and more complicated, then you can use that. Even if you have rest for 140 units, 180 units, 200 units, optimization techniques, they have to be applicable. And in less than most time. Okay, we may use it, but when we have cost function, we have constraints optimization techniques. But these are the mathematical as well as the mathematics techniques. But if images are there and you want to extract the data from some, and if your system is even more and more complicated, then you may go over there. Otherwise, these techniques work well.
So have you considered any local problem in Pakistan, say maybe for LESCO or maybe for any of the private generators?
Unfortunately, find it difficult to get data. Can share that evidence of their dispatch.
I think this needs to be applied. I think we need to work together. We just need to work with the energy department, and they already have several issues that they are trying to handle, but they hardly go for a research. Okay, sure. Yeah, oh, sure. Wonderful. Need to do that. Thank you.
Any other questions?
As Dr. Saab has already apprised you, if you take local case study, local network, local conditions, local case study would provide you some interesting scenario for economic dispatch. For example, we at the time are also paying capacity charges. And on the other hand, when renewables are available, but for certain grid limitations, we are not taking them. Curtailments, the wind curtailments, or even the solar PV curtailments. So this would provide a different solution and difficult task or interesting different task for the algorithm which you are already testing. Because in our scenario, we are also paying capacity charges, no curtailment charges for the wind and PV, and then some network is optimized, utilized, and some other network, for example, existing Matiari Lahore HVDC line is not fully utilized. So the results and these algorithm may perform or provide results which may differ, which otherwise ideally these algorithm may be providing for a certain data set would provide us different guidelines.
Your problem formulation is different but you may set parameters of which and you can get even the solution for all those problems as well. The second thing is that we have to look at some mechanism to get which really stick data and then we can. And these mathematics have enough ability to
Even they would consider the capacity charges which we pay for no generation to the plants.
You can recalculate your problem and definitely maybe one of the essential should consider limits and recalculate the problem. And we have
Assalamualaikum. Sir, my name is Dr. Amir Nawaz. I have few questions. First is, have you considered working on combined heat and electricity energy economic dispatch? Okay. Yeah.
Recording in progress.
Okay, so another question I heard from the other person about the curtailment problems. I think it's an idea. You can tell me whether it's good or bad. We can plan the capacity, RE capacity, before applying it in the power system. So first we will plan it, and during the planning we will apply these different concepts of UC and ED, like unit commitment and economic dispatch, before putting it into the power system. In this way we know that how much renewable energy is feasible for our system. So there should be no curtailment in the running system.
All the units are connected over here. Okay, in unit commitment you have priority is one should be operated. So ultimately they are really such a condition. It's open and idea is to give you say the ability how you can evaluate your problem and solve it.
Okay, thank you, sir. Thank you.
So you may use MATLAB, Simulink. You may use, as the doctor say, artificial intelligence, but they are less popular compared to the optimization things. The platform Python you can use, and Fortran, Maple, Mathematica, these are the various tools that you can use. And you should have good mathematical knowledge. This is a
Now I will invite Dr. Clark, Director Enterprise Research and Development, to come forward and present souvenir to Dr. Clark. Let's move towards the next topic session, which is titled as Evolution of Energy from Stone Age to the Modern Technology and Future Paradigm. And it will be presented by Dr. Akhtar Sool. Let me introduce Dr. Akhtar Sool is serving as Senior Lecturer at University of Botswana, where he is also leading Quality Assurance Committee, Research and Publication Committee, and ICECE and Accreditation Committee at the department and representing the faculty. Earlier, he has worked as HOD, Director Quality Enhancement, Member Board of Studies, Assistant Professor, Lecturer, Lab Engineer, and PA at various universities from 2007 to 2022. The notable institutions are NC University Hyderabad, UAE University Lahore, UAE Texas, SEC Lahore, and Smart Coach. Besides the academic roles, he has also served a vast range of industries through services and consultancy firms. The firms are Responsibility Private Limited, Olympic Energy Systems Private Limited, and Electoral Solutions Private Limited. He is also involved in quality enhancement related OE and OTA training in 9 with the Washington Award. He received his PhD in 2017 from Samansh University, Turkey, MSc in 2009, and PhD in 2007 from the Rajasthan University, Sweden, and UT Award Pakistan, respectively. In addition to a number of training sessions from regular program, TV Power, and many more. His research interests include control and converter applications and high voltage asset life assessments. He is also serving as an associate editor, editorial advisory board member, in addition to reviewing journals from IEEE, IET, Elsevier, Emeralds, Hindawi, Willy, and MDPI publishers. Dr. Akhtar Rasool will join us virtually, and he is waiting online. Please welcome Dr. Akhtar Rasool with a huge round of applause.
history as the human being in itself, himself has the history. And so from the Stone Age, we are always trying to take the sunlight, take the energy from the sunlight, and we were trying to, get to cook the food. We were trying to burn the fire, to keep the home warm, to keep ourselves warm. So this is happening since the Stone Age. And so at that time, that is known as the Stone Age, where we were only relying on the sunlight. But later on, when we moved to the age of fire, where we learned that the fire can be burnt from different sources. So that is a different age. That was the next stage to the modern Stone Age, and that was the age of fire. And after the age of fire, we were having the most important, that has actually lived for a very prosperous time, and for every part of the world, that was the age of fossil fuels. And the age of fossil fuels has really very special history, particularly in the last century, where when the new discoveries were being made in different parts of the world, particularly in the Middle East, and that actually is totally changed the landscape of the whole world, not only from the energy point of view, but also in the political manner as well. It really changed everything, and it changed the balance of the world, depending upon where the fossil fuels and those could be found. But with the passage of time, then we realized that these sources of energy, okay, they are very good. We can have them equally available and can help us a lot. But with the passage of time, then we saw that in some countries, they saw the decline of those findings, or those fossil fuels, and then not only that, limited to that, but also the problems of the pollution and a lot of other problems which came with the fossil fuels actually triggered the human thinking that we need the alternative sources. We need something that we can move to the clean energy sources. So these were the different stages that we are saying, that we moved from the Stone Age to the age of fire, and then we moved to the age of fossil fuels. I mentioned that the environmental impact of the fossil fuels was too heavy, that it has led to the many countries in the world to really look for the alternative sources of energy, and that pushed them to actually change their policies politically and technically, at the country level, and they pushed for the initiatives to be taken at the international level, and that actually where then we found that definitely there are alternative sources of energy. And interestingly, those sources, novel energy of sources, they are actually not new. They were known from the primitive time. They were known from the Stone Age. So the human was really focused on those sources of energy historically from the Stone Age, from the age of fire and those times. But somehow in the transition, the reliance was actually looked into the fossil fuels, especially when the discovery of the methane gas. Obviously, those were discovered accidentally initially, and those accidental discoveries actually led the human being that they have more sources of energy, that they can burn the fire, they can make use of it in different forms. So that's how then, but obviously it was the last century where it has the biggest impact on our whole globe, and that has brought the whole globe actually to a point where it was really leading to the disastrous stage in terms of environmental factors, the impact of it. That was really, really heavy. And so it has moved the human to go back and look into the sources of energy. And then we found that obviously the solar energy is really available, and that was already in use, and so we are now using it in a more modern way, in a more innovative way, and there are various ways, and there are many things which are under consideration and going on in the research from the sunlight, particularly the impact of the sunlight in the presence of the dust particles, fog, and particularly now the smog, because the smog is something that is bringing impact on the solar irradiation, the harvesting of the energy, or harvesting of the current from the solar energy, and that is actually is opening many new challenges and many new possibilities of particularly over there. I would like to mention the topic of identifying the sort of a universal model. But currently we have sort of models which help us to harvest the energy from the solar, but those models are focused for different parts of the world. There is no universal model that we have currently available to us. Yes, they are available. We can use them for all parts of the world, but there are constraints which apply to them. And but we need to move that model to more towards a sort of model which can be fitted in any country in the world, particularly in Asian countries. We know that currently the smog is very serious over there in those countries. So how to fit that model in these countries? Just a moment, please.
Recording in progress.
Okay, so then we move to the nuclear energy, and we know that the nuclear energy, the discovery of the nuclear energy was very important, because with the less amount of investment, we could actually generate a very good amount of energy, and that also has the political and the environmental issues, and obviously it is very safe when we compare to apparently the media is different, but the nuclear energy is actually, when we look into it comparatively, actually this is a safe sort of energy, but it has the issues in the form, if there is a disaster, then the problems are really bigger, but the problems are more on the political side. So this is a sort of energy which cannot be easily be allowed. So that's why there is a limitation of this energy. So that is also sort of the possibility that is not on the cards in different parts of the world actively. So, as coming back to the renewable energy, as mentioned, that particularly the harvesting of the energy from the wind and from the solar, these are the two globally acceptable form of energies, and which are continuously on the cards. And these energies, then when we talk about the solar energy, as I mentioned, I was just mentioning that there are different models that we are trying to validate currently, and those models need to be actually changed and be optimized in such a way that it can account all sort of possibilities which could be there in the air, which could be there in the weather, which could be there in the surroundings, and those are bringing the new challenges, and those are being taken into account, so that to actually really make this solar energy as a successful chapter in the long run in a sustainable way. Yes, it is sustainable in the form that it does not have that sort of, or that big level of the environmental impact, but and it is also readily available, but the consistency cannot be ensured until we don't get the models that that can actually fit in any sort of environment, and then we can actually counter for the factors that could be depleting the harvesting of the energy from the solar. And in the wind energy is also not very new. This was, yes, the attention has increased in the current decade, or 1 or 2 decades now actually. But it was particularly being used in the European countries, where for the remote areas they were putting a single windmill or 2 windmills to help that particular area of the farms. So they were relying, yes, but those were not sort of optimized. They were just running it on the basis of the machine. They could run it, and because it was not really required to be optimized, because that was the requirement was for just a small place. But when we need to use it for supplying the homes and the industry on a bigger scale, obviously now we need to optimize it according to the requirements of the market. And here we are, obviously, there are many challenges which have been overcome now, and there are still some challenges but luckily there is a good research and a lot of good work has been already done on it. And moving to the geothermal energy, this is a type of another renewable energy form that we try to make use of the heat. If we can get the heat, or we can store the heat, then we can also convert it into the electricity. And this has also sort of good work done on it. And so this was another stage in the renewable energy. And as we are moving, I'm moving a little fast so that to meet with the time, because my purpose is to connect with the history and what is going on currently around. And the more focus of mine is on the global new initiatives that has been taken around the world in some form on the smaller scale, but many of us are not aware of those sort of initiatives, and we will be moving fast to that. Biomass energy is another form of the energy that is considered to be a sort of renewable energy source, and it is also replacing the fossil fuels, depending upon how much excess we are getting to it. And so this is another form of or you can say the fourth form of the energy. And another renewable energy source is the fuel cells, and a lot of work has been done and still is being done. And the good thing with the fuel cells is that it does not needs the biggest infrastructure like we need for the solar cells, or we need the windmills. So this is a sort of energy which was already somehow in some form was available or was known to the chemical engineering and some other sectors, but now it is being more focused, particularly from the point of view of the electrical generation on the larger scale. But obviously there are still challenges when we see it for larger scales. So there are different kind of challenges, but obviously a lot of good work has been done on it as well. And this was and coming to the some important points in is the energy efficiency, as I was discussing about the different forms of the renewable energy sources that we have just noted and we all know. And the most important thing over there that we are dealing in research in different forms, sometimes by using this algorithm, that algorithm, and by this topology, that topology of the converters or the different type of the controllers, or the even we are actually trying to, even in the PLL, phase lock loop, that when we try to see the angle situation to match the phases of the generation and on the supply, on the distribution side, over there even a lot of changes have taken place. So all changes or all progress is because of the demand of the energy from particularly from the renewable energy sources. It has really changed the landscape of those focus areas totally. There are a lot of research, even the full programs can be developed, and in many of the European countries there are particularly research centers where the focus is only the solar, because there are a lot of things, because the converters topologies and those things when working for the solar to harvest the energy from the solar. So the converters and the controllers, their topologies as a together there are different forms which are more optimal. And when we come to the wind energy over there, it is different form. And in wind energy particularly, I would like to mention the double-fed induction generator has played a very good role. It is actually the very form of the induction three-phase induction motor. Actually, it is the double wound rotor, actually wound rotor type of the induction motor. That is the actually double-fed induction generator, and that double-fed induction generator has given us the possibility of back-to-back converter control over there. And so like those, as I mentioned, that it has changed even those focus areas of the controllers, the control engineering that is applied to these fields, and the converters topologies, the power electronics, everything is evolving, everything has evolved. So now we are actually in a very good situation where we are luckily moving to where we are moving to the smart grid. And in the smart grid, we know that the lot of things have happened already, but there are a lot of challenges which are being overcome in the smart grid. To reach or to realize the smart grid, actually, we can think of the smart grid as a big building, and the one brick of the building, we can think of it as a distributed generation, or to a more sophisticated manner when you have more type of the sources there inside. Then you can think of it as a microgrid, and then connecting a lot of those microgrid units, you are able to smart grid. The concept of actually the distributed generation is for the sake of meeting the challenges on that small level, on the distributed level, and then uniting those gauges into a microgrid, and then we solve the issues at the microgrid level. And when we know everything is solved at the microgrid level in the form of the on-grid or off-grid, and then we are able to actually connect a lot of microgrids, and we can feel that that the smart grid can be realized, and then we are trying to solve the issue at the smart grid level. But the smart grid actually is really an integration of a lot of technologies over there, and the smart grid is something where the challenges are not gonna finish sooner in time. They will keep on, because the smart grid is something, it is, as I mentioned, it is an integration of technologies. So a lot of things are there which have been solved, which have been tested, and but there are more challenges which are still under consideration. Just for the sake of example, the electric vehicles are being integrated now. So what level of impact those EVs, when they are being charged, how they are going to bring the impact on the smart grid. Okay, currently we don't see the mass level of charging. So, but when the mass level of charging will be tapping into the smart grid, so that is the sort of thing which is still to be realized. As I mentioned, that to some small level scales, those things are being tested and being handled, and people are trying to the research centers and are trying to solve them, but there are many challenges which need to be solved. So the realization of the smart grid is still, is not very soon in the form that actually will be fitting or will be meeting the requirements globally. But the realization of smart grid is not something that is something actually. If we say that once we have realized it, the way we are visualizing it, the way we see the potential of the smart grid, this will actually be capable to meet the all needs of our globe. Not only that, but it can actually help us to have even surplus of energy, which is something is astonishing. Actually, we feel like that. And the reason for that is that we will actually more realize about it when we will move to the initiative, as I was mentioning at the end of these slides. So the Internet of Things is, the integration of the different sources and the status of the grids, the distributed generations, the status of the whatever the components are there, to make the thing simplify, make the thing simple. Look, I am mentioning that they are the components, but component means they could be the DGs integrated into the smart grid, or even the microgrids, because the DGs together some 2 or 3 forms of energies, or for example, solar-based energy generation on a small level, it is a DG, and similarly, small level generation from the wind is a DG, wind-based DG, and similarly fuel cell-based. But when you have 2 or more of those DGs, we can call it as a microgrid. But not only like this way, but that could also be on the microgrid can also be based on only the solar base, but then the scale of the level of the energy handling over there is actually defining. That is how it is defined in the IEEE. So when you bring a lot of those things, you bring electric vehicles, because what we are looking towards the smart grid, with the possibilities of the smart grid that it is offering to us, is that the smart automation, the home automation, and those kind of things, we want to get them, all these things to be integrated, in that smart grid. So that is something is really very fancy at the moment we see, but obviously in the distributed form, we are solving the problems, and the things have been tested and working nicely, and they are confirming that we are heading rightly through our research worldwide. So the Internet of Things has to play a very good role in updating the status on different parts in the smart grid. What is the level of energy at this end, what is the level of energy on that end, and there is something very interesting, as I mentioned before, the smart grid is really an integration of technology. You can think of it, like various units, like, 1, 2, 3, 4, 500 or thousands of units and every unit is actually a microgrid, and which microgrid could be based on many, many DGs, and not. Okay, so those units, we have some surplus of energy at one end, but there is we never know that which path would be the best to route that energy to some other end. So over there is in algorithms, in programming, in algorithms, we know that we have many algorithms which provides us to locate the shortest path, and so those kind of things have been tested to some extent, but still need to be explored more and more, so that it can help us to meet actually really the needs of the smart grid. And meeting the needs of the smart grid means meeting the needs of the energy worldwide, globally. And the Internet of Things has a very important role, because it is integrating the sensors technologies and the communication technologies and the calculation, the cloud computing and everything, and bringing them together in the form that it really updates the status on every node. Node considered to be as a microgrid or smart grid, even smart grid on the country level, So energy store.
Please bring your presentation. We are running short of time. So please.
Okay.
Thank you.
Okay, fine. Thank you. Okay, so the energy storage, we know there are many challenges in the energy storage, and we have handled, and this is also very important, and electric vehicles. We know that in the electric vehicles, leaving the discussion of the electric vehicle, particularly from the point of view of the challenges inside over there. But to us, the electric vehicles are also a source of energy, because when the EVs are not in utilization, they can become a source of generating the electricity from the sun, or even those electric vehicles which are based on the fuel cells. So there are various possibilities with the electric vehicles. So electric vehicles are also the sources of energy they are not only to rely on the power grid, but they can also provide the supply to the smart grid. Okay, all these things alone cannot work. The government policies have to be, formed in such a way to address the requirements and the challenges raised by the from the technical teams, from the research teams. So the research and development, they have to take into account the government or the political matters, so that to solve them. And luckily, some standards are being formed all around the world, and particularly in the United States, very good standards have been formed, and the same path has been followed by the European countries as well. And so without that, this is also an important aspect. So that's why it is mentioned. And challenges in renewable energy sources, as I mentioned before, so I think that would be the sufficient. And let's move to the future of energy, as I was mentioning. And in the future of energy, I will directly go to the global initiative and the global power grid initiative. So the power grid network, having the transmission network around the whole globe. Okay, so having the transmission network around the whole globe is a very complex and challenging task, and that involves technical, regulatory, economically, and political considerations. And as the name is telling, that it is a one word, one power grid network. So can we imagine that there are some countries in the Europe, particularly, for example, the Denmark and Germany, many times they have the surplus of energy, and that energy can be put into that global network. And some countries in different parts of the world, anywhere, they can take that energy, and so that body on which would be operating the global power grid, that will be seeing that from which parts of the world how much energy is being entered into that one, and how much energy has been taken out. So on the basis of that, the charges can be applied to the different countries. And by this way, many countries which are weak, which are poor, which cannot actually help themselves to generate electricity, so those countries will be actually become part of that network very easily, because it will be moving through different parts of the world. Obviously, it is also a point of that from which route it has to be taken. But those are the things. But there are many countries where such initiatives have been taken, on the basis of the continents already, and some infrastructures are already there, and they are trying to test. But obviously, it requires huge investment and huge challenges are there. But it does. The work is not going. The work is really going. Particularly in Africa, there are some countries now which actually have launched a program now where the team of experts is working to actually to lay down a setup which would actually be meeting most of the African countries. And later on, those similarly there is a network in the European countries, and we need a network on the Asian side. and we need network in the Middle East. So those networks have to be then connected. So this is actually the realization of the global initiative. And in this one, as you can see, there are some challenges that I have highlighted. There is the requirement for the standardization of the power systems, because that will be really needed more than ever before, particularly in terms of the voltage levels, because what was happening before that, the transmission lines were laid down depending upon the capacities of the countries locally, and they were trying to have those levels of the voltages and the frequencies, whatever was suiting them, or they were feeling they could manage it. But now when it comes to the global network, we need to more standardize it. I would quote the example of the GSM technology. When it evolved, when it started, the different countries were having different frequencies to operate the mobile communication, but later on they realized they have to standardize it, and then they standardize, and then now we can communicate worldwide, easily without any issue. So similarly, in the power system now, we need to standardize the power systems, to standardize the voltage levels, and different parts, different things in that. So advanced transmission technologies have to be now looked more into details now. We more look into it for more higher voltage levels of the transmissions. So that is the another challenge in it. International collaborations, we need more countries, and we need to convince, actually, we need to also educate we also need to not only to educate the governments, but we also need to educate actually now the research and development teams around the world that everything, whatever we do now, we need to see that at some stage in time now, we have to actually move towards it, because this is something is inevitable. Later or sooner, we are going to this one. So this is something which will be now changing every research with a new look now. So this is something has to be taken very seriously into account, because this is totally out of the picture at the moment. So interconnected regional grids, that is also have to be seen is a sort of I don't know why it is. Okay, sorry, it moved. Okay, so the regulatory framework has to be formed. So these frameworks at the moment, they are available, but they are available not with the global perspectives. They are available, even the standards which we can see in the IEEE, those standards have been written for the regions, or from the point of view of the microgrid, from the point of view of the smart grid, but the smart grid not on the global stage. Okay, so those frameworks have to be really now, the work has to be started. And as I mentioned, that the work is also going to some extent, but this work has to be now moved to every part of the world, that everywhere the people in the academia and those people, and also the lecturers should see that this is something that where we need to educate the students as well, so that they look into the problems according to this. And the other challenge is the investment and financing, and obviously educating the investors about it, the potential about it. The potential means it is really going to change the landscape of our earth, of our whole globe. So definitely the potential in it is never compared. It is the way I see. I feel like that the potential it is going to offer us, I don't think so there is any parallel potential that has been ever offered by any business. So the power grid is the global power grid is something is an initiative that is going to actually feed, I don't know, many people around the world, and the investors as well. So the political cooperation, it is also one of the challenges and to be taken into account, and environmental and social considerations, because while laying down the new network, there are some new social things, and also it is also a matter of convincing the public. So over there is the work is also required. So the regulatory framework, I already mentioned, the risk mitigation, the disastrous situations, to how to deal with those. when we deal with the disaster, when the problem appears to the microgrid, or when it appears to the hydel power base. So those parameters, or the way it was being looked, it was different. But when we have to look it as a global network, we have to really, there is one concept which is divide and rule, is a sort of, you make the distributed form of, just like we are already working in the smart grid. So similarly, in the units form, even on the country level, and similarly growing and taking it bringing it at the university, at the globe level. That is how we can actually find a way to mitigate the risk. So the public awareness and support is really needed into this one, and because of the shortage of time, the next my example, I will not go into the detail of that, but I will just show you the possibility of is the Global Fast Rail Initiative Network. Okay, this global. We know that the fast-speed trains are running in China and Japan and in Korean countries particularly, and obviously now many other countries in the Europe and those also have them. But the way they are there in the China and in Japan and Korea, they are actually leading ones, and they are actually to bring a lot of possibilities of helping us in meeting our not only meeting. Obviously, it is also a big source of consuming the energy. But looking into it on a global perspective, and this can also run beside the transmission lines, to meet, to not only to commute the public around the world easily, because currently we are more relying for bigger travels on the air flights and the air buses. So that is needed to be moved to the rail network, and by this way that whole invest can be moved to the rail network as well. And the rail network at the same time, when those are being used, they are consuming the energy, but when they are not in use, they can actually help us to generate the electricity. And you see the scale of those installments, the scale of those long rail cars, that is something, is a big source of energy which has to be tapped in. And with this one, and because of the short of time, otherwise I was also having listed not only the challenges and the possibilities, actually more into detail about this example. And I would now request for the questions, if there are any questions, please.
Thank you, Dr. Sir, for a very interesting presentation and highlighting the emergence of energy from fossil fuels to renewables and just generating a lot of things like that. Just a simple question for the sake of students, because we have a number of students over here. When we introduce some renewable energy source into microgrid, definitely the current contribution and the voltage deviations are there. So how can we snub them? Can you set some mechanism control to handle these deviations in current and voltage of a bus?
Okay, thank you. Actually, it is a very nice question, and it is actually a very good question that is already, there are IEEE standards which are actually addressing this part particularly, and the protocol has been already defined. And just for the realization of as you mentioned, for the students, I can try to connect them with the concept of parallel alternatives. The generators are working in operation, over there, we cannot take something out, immediately, and we cannot bring something, without a certain protocol. But here we have actually more challenges because the momentum or the inertia of the system is not as strong as it is in the machines-based power generation systems, and particularly the machine-based, which are on the hydro, energy, and the fuel cell-based, the fossil fuels. In this one, there is a big challenge of the intermittency, the strength of the microgrids, and the concept of that's why there is a concept of weak grid. There is a concept of weak grid, and there is a concept of infinite grid or strong grid, because the way we see currently our infrastructure, the power companies, they keep on giving the connections. They feel that their system is sufficient to accommodate many more. Many more homes. So generally they think of that system as a strong microgrid, a strong grid, or a sort of infinite grid. But when we come to the microgrid, the biggest challenge is, or even the distributed generation DGs, we are facing the challenge of with it is a weak grid. We are trying to sort out that with the help of keeping some the backup batteries and the storage system, with the help of which we are actually managing it. But that is still sort of insufficient, and it has to be tackled with more strong or more better or fast controllers. And but that alone will also be not sufficient. So this is a sort of challenge at the moment, and that's why the simulation of the weak grid should be done at various scales as well. And that if any one of us, sorry.
Any other question from the audience? Thank you, Dr. Sir, for sparing time and giving a wonderful keynote speech. Thank you so much.
Okay, thank you. Thanks a lot.
Thank you, Dr. Akhtar Rasool. And let's move towards the next talk of this session, which is titled as Energy and Power Policies of Pakistan, Prospects of Energy Transition, and it will be presented by Dr. Nayyar Hussain Mirjat. Let's have a brief introduction of Dr. Nayyar Hussain. Dr. Nayyar Hussain is an engineer by profession. He has earned bachelor's and master's in electrical power engineering and doctoral degree in energy systems engineering. Following spanning 10 years in the industry, he joined academia in 2012 as assistant professor at Mehran University of Engineering and Technology, Jamshoro. He has published 50 plus research papers in national and international research journals and presented 10 plus research papers in national and international conferences. Dr. Nayyar took field of research for his PhD thesis, which was related with energy model, policy analysis and market research in the energy sector of Pakistan. His PhD research was funded under Pakistan's Strategy Support Program of PSSP USAID in collaboration with International Food and Policy Research Institute, Washington DC, USA and Planning Commission of Pakistan. He was also awarded multiple travel grants by HEC to present his research work at international conferences held in Iran, UK and Singapore. Based on his research contributions, he has also been member of Energy Working Group of Energy Wing, Planning Commission of Pakistan. Dr. Nayyar presently is serving as Associate Professor and active member of Energy and Environmental Research Group at Mehran University. Please welcome Dr. Nayyar Hussain with big round of applause.
Very good afternoon. And thank you, the organizers of this event, for providing me this opportunity to discuss with you the energy and power policies of Pakistan and prospects of energy transition.
लेकिन पता नहीं नॉइज बहुत आता है मेरी तरफ ना मुझे कंटिन्यूअसली आई डोंट नो कि इट वाज रियली
The contents of my presentation, which mainly comprises of three sections. In the first section, we will be discussing energy and power policy of Pakistan. And in the second portion, we'll see how energy transition is emerging and its potential within Pakistan. And finally, we'll conclude with a recommendation and conclusion suggestions. Okay, thank you. So I've been asked to move quickly, although 40 minutes time was allotted. Anyhow, I will try to conclude as soon as possible because majority of the things are pretty basic and majority of you are aware, but I would try to provide you some insight. So this slide pertains discussing the importance of power and energy. It is well known fact that we are losing on account of GDP growth with power shortages around and energy crisis, which we have from 2006 onwards. We also aim to achieve sustainable development goals, particularly SDG 7 and SDG 13 pertaining climate change, and still lacking in managing our power sector problems, both at planning and operational level. So, sorry. Now, with this background, let me just little brief you about energy planning and policy. Energy planning pertains assessing a large amount of data, pertaining resources, technologies, and generally, it is well undertaken care by the various energy models, methodologies, which are highly acknowledged, and we need to effectively use them with certain capacity building efforts. Once these planning studies are appropriately undertaken, the next thing is to devise policies out of these planning studies. These policies provides you the programs, and under these programs we have annual development, 5-year development, or 10-year plan, which are then implemented towards delivery of energy, which we are lacking. If we look at Pakistan's power sector perspective, energy as a formal sector was recognized too late, and when it was recognized, it was alone recognized as power. And energy as an integrated approach in a multiple career manner was not taken care of. However, if we look back at the planning studies undertaken or the focus in early 60s, it generally developed focus on the development of various hydropower plants. Water management was the priority rather than the power sector. Nevertheless, we had that period, and in 1990s, power or energy was formally recognized as a sector. In this period, as we came out of Soviet war and our own issues started emerging, we realized we need to deregulate power sector, and with assistance from various global funding agencies and financing institutions, we conceived that we need to bring in some reforms in this sector. And all these reforms appear very well designed, and implementation of them could have delivered much better situation which we face right now. We were promised in this conceived reform that we will have integrated energy policy, consolidated, fragmented energy governance. We were required to build capacity. Until then, we had no regulator. By early 90s, until NEPRA came in 1997.
we conceived to deregulate the energy sector. We were promised that we will attract investment, make generation efficient, reduce T&D losses, hydro and coal. Their potential needs to be exploited to the full, and more renewable and energy efficiency. All these reform agenda appear very good, but unfortunately, we could not have implementation as we conceived. And what we have within our planning domain so far, that before 90s, we had hardly two major studies reported in the literature, or even the government's database. One is the Left-Tank report of 1960s, funded by the World Bank. The other one was the RESPARC model. This was funded by the USAID. In the first case, the was the focus, whereas in the second case, it was an econometric study focusing the energy efficiency and conservation. Under the reform agenda, then we had other studies which started from 1994 and still to date, we are undertaking various planning studies. As I have apprised you, the 4 decades of energy planning and policy, which we have seen, have a lot of studies, a lot of planning effort, but then appropriate policy development and then delivery, we will see shortly. Another important study was in 1994 by the Water and Power Development Authority, National Power Plan, and other study was the Energy Security Action Plan by the Planning Commission in 2005. The focus of this study was the electricity from hydro and indigenous resources. This study of 2007, the PAC-IM model, this was one of the, before ICECE, this was one of the most comprehensive study under a technical assistance from Asian Development Bank, UT Texla, NAD University were part of this study, but unfortunately, following 2013, because energy model required that they are updated and adjusted as per demand, but due to lack of capacity building, we have lost these studies and models, particularly this important study. In 2014, we had Vision 2025. Other than that, from NTDC, on yearly, we have demand forecasts based on regression analysis and market survey. They provide as per their license requirement every year. These 2 studies we have. NTDC also undertook another study in 2011. It focused generation and transmission expansion plan. In 2015, JECA came for rescue, and we had another study, planning study, which was termed as least cost power generation. And recently, we have ICECE, which is a brand planning study under which we have electricity policy 2021 and electricity plan until 2021. These were the various policies. I have apprised you that once we have energy planning or power planning studies with us, we need to devise the power policies or energy policies. Practically, these studies could have helped us to devise very appropriate power policies. But if you would review these studies and review these policies, you would hardly find any substantial connection, leaving the planning effort by engineers and scientists just a futile act. In 1994, our policy started with thermal IPPs, which was shifted later towards hydro. In 1995, in 1998, we realized that we should opt for competitive bidding in either case, for thermal as well as for the hydel case. In 2006, we had first ever RE policy. Since establishment of AED, in 2003, it was passed to introduce the RE policy. Its implementation period expired over 2019, and we had ARE in 2019. Anyhow, later on we had energy conservation and rental power policy in 2010. Cheaper fuel was focused in 2012 policy. Conservation was again focused in 2013 policy. Hydro, clean and cheaper fuel altogether was focused in the 2012 policy. 2021 existing policy period 2031 under ICECE. So planning studies and then policy endeavors, how they have impacted our energy power scenario. If you look at this diagram, we have coal, production and consumption figures, which you would see are lot variable, except the imports, which contribute great in our fuel resources. Around 60%, 63% of fuel for power generation is imported. Rest of the resources we have are so far compromised with respect to utilization, are diverted to the sectors which doesn't actually need. For example, we are in agrarian base. The natural gas should be diverted for the fertilizers. We need cheap fertilizer to contain the inflation of the agri-business. But we have diverted at some time within these policies natural gas for power generation and even for the transport sector, and the results are in front of us. We are ranked 137 for energy consumption per capita, hardly 666 kilowatt hour per person, which is lowest in the world, amongst the world. Not lowest. Energy consumption per GDP, we are ranked 124, and GDP at purchasing power priorities, we are also ranked 23. So I'm just trying to demonstrate how these planning studies and policies have been unable to deliver us. And the slide over here, you will see the current status for 2022. We are still relying on thermal, and this share has started rising since 1991. Then how come the planning or reform agenda, which was conceived in 1990s, have delivered to us? How come the various studies which we have undertaken with a lot of effort, with technical assistance and with funding and financing and policies devised, could not bring a sustainable mix of power generation? And still, right now, you would be already aware, we are probably grid-connected electricity is in excess than our demand. And we still pay for the capacity charges from the thermal power plant for being ready to supply to the grid, but not generating a single unit at substance. Situation is bared by none else but by the consumer with expensive electricity, which we are being supplied, and then we are unable to pay, and a situation which has emerged known as circular debt of power sector, which we'll discuss shortly. So thermal is dominant for generation. Nuclear is a potentially alternative fuel with no emission during the operational phase, can be considered, can be developed, but the security conditions and political instabilities could not provide the substantial fuel to progress. The share of renewables in 2022 was hardly 4%, which has raised to 6% for 2023. But overall, the picture which is over here is not as encouraging, and this could be attributed for this period that we have from 1985, while we had, I have the article in 1985, because renewable have started to be part of our energy system, power system from 2033, while AEDB was established. And then in 2006, we had first ever RE policy. But before that, hydro is also considered globally a renewable energy source. We somehow put RE separately. But this share was excellent, 67%. The period 1947 to 59 until 1977, this had raised and reached its peak in 1985, 67%, and in 1989, and since thermal IPPs and other policies have came, you can see the thermal share has become dominant, as that of 67% hydro share was in 85. We have thermal share of 67% replacing in 2020. And right now, our focus is altogether on RE increment. Yes, that's required, but altogether we need to focus on the hydro share as well. Globally, it is considered as a renewable resource as well. So, if we look at the consumption patterns, unfortunately, globally, the electricity should be consumed for productivity. But our productivity, which comes from agrarian sector and industry, is minimum. 49% of the electricity we produce is consumed at the domestic sector. So hardly effectively contributing in the GDP growth. Domestic consumption is a personal agenda of every household. So as I have already apprised you, our per capita electricity consumption of 644 kilowatt hour is among the lowest in the world, which is only 18% of the world average, 7% of the developed countries, and only 12% of China, as per status of industry report of NEPRA 2022. And the worst thing we have seen over the years is unfortunately the emergence of circular debt, which stood at 2,467 billion. This implies that our circular debt is 3.8% of GDP and 5.6% of the debt the government of Pakistan owes. So this is another debt we have with us, which needs to be resolved. So these have been the key challenges which has brought us in this situation: lack of coordinated planning and policy, lack of governance and mismanagement, political instability, fuel mix is extensively expensive, and then unreliable supply with no transmission distribution system upgradation. Ultimately, we have expensive electricity. And when we have expensive electricity, we do not pay for it. Masses do not pay for it. We have a sort of unwillingness for various sectors of consumer which avoid paying. We have theft issues, governance issues. Then to address that issue, we have subsidies, political stubbornness to continue with subsidies, and administrative and line losses. Technical standards report that these losses should be reduced from 7% to 4%, but we had incremental increase over these losses. And altogether, of course, integrated planning effort is required. So another issue which we are unable to settle so far, apart from planning studies, policy endeavors, and the governance, this is a governance issue. We are unable to so far stick to any structure of the power sector. This structure is evolving continuously. Recently, AEDB was merged within PPIB in June 2023. Previously, the financial function of NTDC was shifted to CPPA. PCREATE is with Ministry of Science and Technology, Pakistan Council for Renewable Energy Technology. So we do not contain this movement to somewhere and adopt certain practices which are worldwide accepted and structure up for once this power sector of Pakistan in an amicable manner, which deliver us. Probably one thing which has happened and is delivering, I am coming from Karachi, I have resided and worked in Karachi for over 5 years. Right now, K Electric, with this, although their tariff is higher, and there are grievances from large consumers, but service delivery has far improved. they rush for net metering. You put up application of your solar PV installation, they would visit you instantly for the net metering. This is not so easy for other discos. So, but regulator and government has certain issues with privatization, and certain people from industries are not happy, but service delivery is out there. So we need to work out some model we'll be discussing shortly. So we have arrived at this situation of energy crisis for all these reasons which we have discussed: expensive generation, limited renewable energy mix, whose tariff has remarkably reduced over the past couple of years. Sorry, I have again exceeded the time. Just allow me 10 minutes to complete up. And then we have a high population. 7% is the demand growth, which we need to match up with our supplies. And we are in this situation. Another contributor to this growth is the low-cost imports of various devices. The comfort of life have increased for the masses, and they want electricity. So given this situation, we have experimented with hydro, thermal, and all other privatization, all other measures. We need to take this chance as well. Energy transition is a pathway toward transforming the energy sector from fossil fuels to renewable-based zero carbon regime. So this could provide us much better passage of reducing costs and achieving sustainability as envisaged in Sustainable Development Goal 7 and SDG 13. So these 4 Ds, if adopted and encouraged in the energy and power sector, the achievement of transition would not be a great problem. We have already listened from our previous speaker. Energy resilience can be achieved through decarbonization, application of Internet of Things, digitization, decentralization, and democratizations. Customer choices. We have CTBMC in place, but its implementation is still carry a lot of questions, and a lot of work needs to be done by the regulator. So deployment of policies, integrated policies, enabling policies, these 3 things could deliver greatly, and then structural changes to adjust these policies. And finally, we need to avail the transition partnerships, carbon credits for installation of PV, for the installation of wind. These partnerships needs to be explored and availed for the cause of energy, economy, society, and planet, and ultimately for our homeland. These are the global prospects of the renewable energy transition. International Renewable Energy Agency targets net zero emissions from electricity, transport, and industry, buildings, and different sections. We can be part of them, although this is probably a more optimistic scenario, but we can move towards certain tangible reduction through transition. We haven't achieved RE 2006 and probably missed the targets of RE 2019, but certain share has been achieved, and we can increase that share and become part of this global exercise. We can take advantage of determining the energy transition index introduced by the World Economic Forum by ourselves. They have worked out for us. But we need to undertake, considering our own condition, our own transition readiness. Transition index allows for evolving energy system performance as measured by the system's ability to support inclusive economic development and growth, secure, reliable access to energy, environment, and sustainability. So its readiness surrounds around this energy triangle of secure access to secure and increasing access to electricity, environmental sustainability, and economic development and growth. And these are the readiness parameters based on which indexes can be determined. They have done away it for us, but we need to take initiative According to this forum's 2023 report, our index holds 107th globally with a score of 46.9 of ETI from the period 2014 to 2023, thanks to these two policies, which has brought some share of renewables. Green index by MIT suggests we are in 67th amongst the 76 countries they have considered. So these indices highlight the lack of sufficient initiative aligning to the country's commitments to energy transition efforts, which call for accelerating its energy. We have a lot of opportunities, challenges, and certain weaknesses. I would conclude it quickly. We need to financially mobilize the investors towards technology development. Technology transfer could be an absolutely right choice for us, but financial stability is required for it. And then opportunity, once we have transition, we would be containing the climate change for not only this region, country, but could reduce global emissions as well. So energy transition partnership is another opportunity, and we have certain strengths which we can account into this transition pathway, like nationally determined contribution as per Paris Climate Agreement we have provided to them. It provides 50% reduction by 2030, but majority of it, 35%, are conditional to the financing. Again, we lack in finance. 15% we have agreed that we probably provide unconditional. ARE policy, I have already discussed, is targets dissemination of technology and more generation of electricity from RE resources, and ICECE is also encouraging development. These are our strengths. Coming towards our potential, you can see this dark yellow area onwards is having excellent solar PV potential. And so is the case of wind. These marked areas, particularly Sindh and Balochistan, have huge potential of wind. I was reading some studies that suggest Dalbadin, Chagi are the location which has highest both wind and solar potential. But of course, they are off-grid. Interconnected grid is out, not there. We need to consider and take into account these potential in our transition studies. So is the case of biomass. We have substantial biomass, including crop residue, animal dung, agriculture waste, forestry waste, municipal solid waste that needs to be accounted in our overall and if I summarize them for you quickly, okay. So using NREL, National Renewable Energy Laboratory's same system advisor model and logistic modeling in an NRPU project funded by Higher Education Commission, under this study in 2019, we worked out theoretical and technical potential of various renewables of Pakistan. Hydropowers, let's talk about technical potential. We don't go with the theoretical potential. 17 million ton. Right now, our energy requirements are around 80 to 90 million tons of oil equivalent, whereas hydropower's technical potential is 17 million ton oil equivalent. Solar, 240 million tons oil equivalent. Wind, 62 million tons oil equivalent. Biomass, 8.6 million ton oil equivalent. Altogether, they become 327.65 million tons oil equivalent. Considering this potential, our RE is almost 4.4 times higher than what we have with us demand. This is a very interesting situation. More encouraging trends we observe from the NEPRA's tariff determination based on the global reduced prices of the solar PV and wind. Recently, we have 4.7 cents per kilowatt of tariff from the regulator, which has reduced from the higher tariff. This is a very encouraging situation. So the one concern of higher tariff is being addressed. So is the case of PV 4.8 recent cost plus tariff. So given this whole discussion and the chance we have provided to various energy indicators in the past, we have also undertaken the SWOT analysis of strength, weakness, opportunities, and threat analysis. If Pakistan moves towards energy transition, we have strengths, we have already discussed, huge renewable potential, climate, environmental benefits, reduced health and environmental impacts, public awareness support is there, international assistance and financing is available. We can have a chance, if we have IPPs, thermal IPPs, why not? We go with transitional potential as well. We have reduced tariff opportunities or energy security. That's a huge thing. We will achieve green job creation, rural electrification and distributed generation. And with technology transfer, we will have technological advancement. We have certain weaknesses, limited grid infrastructure, financing constraints, technological constraints, and workforce transition constraints, land use issues, that's debatable for certain cases. Policy and regulatory challenges we need to address. We have now sufficient capacity of a regulator. We can adopt transition more quickly. And lastly, the threat is the political and socio-economic resistance. We need to tackle it. But I would say if we weigh both strengths and opportunities, they would outweigh the weaknesses and threats. So I would come towards the conclusion of my presentation and apprise you. At this moment, the simplest recommendation would be we should enhance our transmission system capacity with existing improvements in the governance. So our transmission is not capable of carrying the electricity which could be generated. 2023 witnessed maximum demand at NPCC of around 29,000 of megawatts, whereas our installed capacity is above 40,000 megawatt. We even pay for the capacity charges. And even we go with curtailments with wind, not having any production, although wind season and windy weather is out there. So we need to improve. We shouldn't go at this moment for any capacity addition for the short run. Yes, for the medium run, we have other recommendation. We need to improve the governance. We need to enhance the adjustments to the ICECE. We should not miss this opportunity as we have done in case of Pak IEM. We had lost that opportunity, but this opportunity of ICECE should be kept live until its planned period of 2031. Then providing industries, large consumers of 1 megawatt of above, a competitive trading bilateral contract market, giving them choice to opt for electricity from any source would encourage them, would reduce the production costs of the industries. And in medium to long term, you'll find that in the short term, there's no energy transition related recommendation from my side, but in the medium to long term, yes, we need to develop an energy transition plan with clear targets, medium to long term policy and regulatory framework, establishment of energy transition, global energy transition partnerships, public awareness campaigns to push political forces to consider the cheaper renewables. And if you say I should conclude it, realizing energy transition require a comprehensive action plan based on holistic approach along with clear targets, timeline, policy, continuity, regularity, clarity, and stakeholder engagement. Institutional capacity of energy-related government agencies, regulatory bodies, and research institutions, academia needs to be enhanced. They should be taken on board with these efforts. So this is what I have some references and apprise you. We have been at Energy Environmental Engineering Research Group, Mehran University, publishing on Pakistan's power sector, on transition, energy sector, These are the couple of publications which I have also cited in this research. And thank you for your any questions, suggestions. Although I have run out of time, sorry again for it.
So can we take a question? Or we are late? Okay. Just very quickly, a wonderful presentation. Thank you very much. It summarizes all the policy matters and issues Pakistan energy sector is plagued with. You did mention about renewable integration and its expansion. Can you comment on overall demand increase in Pakistan since there are so many industries which are switching towards their captive generation? So what is the real demand increase forecasted on the grid in Pakistan at this time? And we have north-south grid only. And you talked about so many renewable sources elsewhere. So what is the possible opportunity to handle these two issues?
Very relevant question. Unfortunately, I have myself served in WAPDA and worked over power plants as well before coming to academia. Data is one of the major issues. If I ask you, your consumer bill may possess your connected load. I have connected load of 1 kilowatt on my bill. But actually, how come it is 1 kilowatt? Only inverter AC of 1.5 tons is 1.4 or so. So data from consumer, data from the power plants, data from the transmission is somewhat really ambiguous. We don't have reliable data. So I can't provide you any estimate that how much is the demand. What we have from the consumption, our demand is around 100 terawatt hours, which is from the interconnected system. This is from the NTDC data. 100 terawatt hours can be delivered from any capacity with good efficiency power plant from 25,000 to 35,000 megawatt. But since we don't have correct information from the industries for certain reasons, because they need to pay for the maximum demand as well, and the fixed charges if they disclose their loads. So in such situation, we need to improve governance, but simply from the data, it is realized our growth is around 7 to 8%. And with industry realizing that we have expensive electricity, in absence of the choice they have, they are of course going for captive power plant. And a lot of industries, I tell you, in our region have opted for solar. 1 megawatt, 2 megawatt, 3 megawatt. They are opting for it and their costs have reduced. So, sir, data is a challenge. I even won't be able to provide you guarantee for the data I have presented. I have reported data from the literature, from the reports. So this is the major constraint which we need to right away correct from our residents. Let us provide correct load to the LESCO, HESCO, that our load is there. They would only charge you a security difference of security deposit. And then ask them, now you provide the right data so that we can plan and consume appropriately.
Saulab, sir. Sir, my question is about electricity market. As from your presentation, I see that Pakistan has not come towards this topic. While in 2011, I have attended a meeting that was in UT Texla, and there was a seminar with India, and they were discussing about the electricity market in India, their visibility and everything. So first thing is, I want you to comment about the electricity policies, if there any policy going on in Pakistan under discussion or anything. And the second thing is, one thing we already have that is a step, that is net metering. It's a kind of a step that can lead to electricity market. So I want you also comment on some steps we should take from converting the net metering to the electricity market. Thanks.
The market trends, electricity market electricity is a modern day commodity. So like all other commodities have markets, you have open choice to purchase from any mall. So does electricity should provide you choice. Even we have cellular choices. You can have SIM from any service provider. This has been realized very lately. Under SARC initiative, yes, there have been discussion. I have also attended a couple of meetings. Recently in 2021, we had some initiative that 1 megawatt and above consumers would be allowed this choice when 11 kV feeders would be prioritized. But these initiatives are still to be realized. NEPRA is working on it. CTBMC, I have apprised you in the presentation. So things are on track, but the process of privatization, the transparency, and making right choices is a challenge which needs to be addressed with political stability. Now coming towards the other part of net metering, like I have apprised you, K-Electric is a lot encouraging consumers to let them know if they are going for net metering. They would facilitate it. This is not case of other discourse. For certain reasons. The key reason is our network configuration. Transformers are not well load balanced. There are conditions of express feeders. For example, in my region, HESCO won't go for SEPCO won't go for net metering if feeder is not express. And they would only have electricity net metering on 400 kV. So net metering regulations or implementation would only increase if we are able to stabilize our distribution. ये जो आए दिन हमारे पास trippings और ये सारी चीजें unfortunately होती रहती हैं, this seriously damage the system's performance. Even there are incidents where consumer have suffered. They don't go for net metering in certain regions. So this could be achieved by standardization of devices and implementation of operation guidelines at distribution level. Then possibly this would be a great source. There was a report, I was reviewing a couple of days, that if we take data from customs, how many solar PVs have been imported for last 10 years, it's probably higher than the installed capacity of Pakistan. So we don't know how many these are installed, where are they installed. So this is an issue of data, operation, maintenance. These things can improve our performance. Thank you very much.
I will request Dr. Ghulam Abbas to present souvenir to Dr. Nayir Hussain. Please come forward. Now Dr. Waqar will present souvenir to Dr. Ghulam Abbas for chairing this session. Thank you, sir, for your valuable contribution. Now we will have prayer break. We will resume again at 2 p.m. So please go to the break and come again at 2 p.m. sharp. Thank you.
Recording stopped.
सब लोग काइंडली बाहर मीडिया वॉल पे जाइएगा, इस सेशन के लोग, हम एक ग्रुप फोटो लेंगे। थैंक यू।
several leading public and private sector organizations in Europe, Middle East and South Asia. He has authored 8 books and has over 100 publications to his credit. He is part of several national and National Energy Advisory Forums. Dr. Muhammad Asif will join us virtually today. Please welcome Dr. Muhammad Asif with huge round of applause.
Okay, okay, Assalamu alaikum and good afternoon, ladies and gentlemen, and the conference organizers. Please confirm if you can see the slides. Right, okay, thank you. So I have 30 minutes. I'll try to I think I have 45 minutes. I'll try to wrap up in 30 to 35 minutes to allow some time for questions and answers if there are any. Okay, so the title of my talk is, let me switch to Role of Digitalization in the Low Carbon Energy Transition. And the key points I would like to discuss in my talk are energy systems, an overview of energy systems and global energy landscape. Then I'll come to energy and climate change. And the third point I would like to discuss is low carbon energy transition. And then digital technologies for energy transition, the prospects and challenges of digitalization and digital technologies, and then I'll conclude. So, in terms of energy resources, the energy systems we are living with can be broadly classified under 3 categories. The first one are fossil fuels, which include oil, gas, and coal. Then we have nuclear power, which comes in nuclear fission and nuclear fusion form, though presently we are only employing nuclear fission. And then we have renewable energy, which comes in many different forms, including solar energy, wind power, hydropower, biomass, geothermal, and wave and tidal power. So these are the 3 broad families, if we can say, of the energy systems that we are using. Now, in terms of contribution from these energy systems, fossil fuels, oil, gas, and coal, they are collectively contributing to 81% of the total primary energy supplies. And in terms of emissions associated with them, 63% of the emissions are coming from fossil fuels, and then about 37% from non-fossil fuels. When we look at the these are the figures, the earlier figures for the power sector. And then when we look at the complete energy sector, of which power sector is a part, then about 84% of the total emissions, they are coming from fossil fuels. The low carbon technologies, they have a share of only 15 to 16%. So the bulk of the carbon dioxide emissions and greenhouse gas emissions associated with fossil fuels. Then, now in this context, when we look at the energy transition, the concept of energy transition it's a pathway towards transformation of the global energy sector, including the resources, the technologies, the utilization from fossil fuel-based systems to zero carbon energy-based systems by the middle of this century. Now, this is not the first time we are talking about energy transition. Actually, the first energy transition in the known human history was the switchover from biomass to coal in the 18th century with the steam engine, which transformed the human civilizations and which propelled the Industrial Revolution. Then the second energy transition is said to be what happened in the last century, when the world moved from coal to oil and gas. which are more efficient and easy to transport logistically, and which are more economical. And now we are witnessing the third energy transition, which is also said to be sustainable energy transition or low carbon energy transition, or the 21st century energy transition, which means we switch away from fossil fuels to low carbon and sustainable technologies. So this is what we were traditionally for the last couple of centuries and even before, counting on primarily fuels, and now we are trying to switch over to renewables. This is, in a sense, a graphical depiction of the energy transition we are trying to accomplish. Now, what are the main drivers of this energy transition? The first driver is rapid growth in energy demand. The global energy demand is growing rapidly, and in the first 50 years of the century, the demand for energy is expected to grow by 120%. Now, fossil fuel reserves, which provide over 80% of the total supplies, they are depleting around the world. Now, on one hand, our demand is growing, and on the second hand, our bulk supplies, they are receding. So it poses a big challenge. Now, energy better than you guys in Pakistan. The effect of energy prices on the livelihood and everything across the board. And then there are security of supplies, both in geographic terms as well as in terms of what is the main, the modern concept of energy security, that there should be three conditions to be met. First one, there should be adequate energy. Secondly, it should be reliable. And thirdly, it should be affordable. And when we look at, for example, Pakistan, neither we have adequate energy, nor it is reliable. Even in cities, we have 10 to 15 hours of load shedding in summer days. And affordability of energy is, we are all suffering from that. And thirdly, it is energy deprivation, which is also, and next is energy deprivation, which is also a component of energy insecurity. And finally, climate change, which is the biggest and the most important driver behind this energy transition. Here is a quick overview of the jump in energy prices in Europe in the wake of the Russia-Ukraine war. So just imagine two countries have a dispute, and this dispute is affecting the energy prices all over the world. And in Europe, gas prices, for example, increased by more than 600% within a matter of 1 year. When we talk of energy deprivation, here we see the regions which do not have access to electricity, and according to United Nations estimate, about 1 billion people do not have access to electricity. Now, the definition of electrification is also political in some places. For example, in some places, if a village just has a single electric lamp, it is said to be electrified. Now, even considering those compromise definitions, still 1 billion people do not have access to electricity. And even those who have access to electricity, a lot of them are suffering from the grid reliability. And Pakistan is an obvious example. And the same is the situation in most of the developing countries. And now the second figure, it shows us the lack of access to clean cooking fuels, and about 3 billion people, mostly in Africa and Asia, they still are counting on biomass, on wood, to meet their heating and cooking requirements. In our neighborhood, in India alone, there are almost 600 million people, they are living on biomass. And then there is energy security issues, and as I said earlier, energy has to be adequate, it should be accessible, it should be affordable. And now in the wake of climate change, there's a new dimension added to energy security, which is called energy acceptability, which means the energy should be coming from the resources which are environmentally acceptable. For example, they are renewable and clean energy sources. So these four should be met to qualify for energy security. And if we again look at Pakistan from this lens of energy security, neither neither we have adequate energy nor the accessibility of energy is there, because probably more than 30% of the population in the villages and remote locations, they do not have access to electricity, and people do not have those villages where we supply gas pipeline and we supply those of news stories and flashy stories. And the affordability of energy is in front of all of us. I'm a frequent visitor to Pakistan. I belong to Pakistan, and I have been covering the energy scenario of Pakistan for the last 20 years. And I hope I don't need to educate on this is a household challenge in Pakistan. All 250 million people, they are suffering from it. And finally, acceptability. Well, we are overwhelmingly relying on fossil fuels, and we are going more and more towards coal. So it tells us the story with regards to acceptability. Climate change is said to be a global problem triggered by the human use of fossil fuels. So here's a modeling of greenhouse gas emissions since 1000 AD. So obviously it's a modeling, but we see since the Industrial Revolution, until the Industrial Revolution, it was pretty much a flat scenario. But now there's an acute jump. So this is somewhere we are now, and in a business as usual scenario, this can be the window of possibilities. And this global warming is leading to high temperatures and loads of implications we shall reflect in coming slides. Now, the interesting thing about global warming that its implications will not be uniform. They will be random, they will be abrupt, and they will be intense. Some parts of the world will become very hot, the others may become cold. The other parts of the world may become dry, and people may suffer from severe lack of rain, and the other parts of the world may see intensive rainfalls. We cannot really predict very precisely how different parts of the world are going to suffer from climate change. Now, the most obvious indication of climate change is sea level rise. As the global atmospheric temperature rises, glaciers melt, which are a very important part of global ecosystem. And when the glaciers melt, there's more water in the sea. And then the low-lying countries, like, for example, Mauritius and Maldives, and there are probably about 45 countries which are said to be low-lying small island nations which are facing existential threat. And even the bigger countries, like, for example, Bangladesh, some forecasts say by the end of the century, 1/3 of the country could be underwater. And for a country like Bangladesh, which has so huge population considering their land area, this is a huge problem. And then the sea level rise is leading to incursions on land, by the sea, by the rivers, and then we see flooding, which are becoming more frequent and more intense. And I think I think in 2022, probably Pakistan suffered from the worst flooding in its history. Probably a third of the country was underwater. And you know, when there is flooding, people lose everything, all their belongings and livelihood, and all they can barely manage is to save their own lives. And these scenarios, they are now being witnessed all over the world. And global warming is also leading to seasonal disorder. And like we human beings, we need a particular set of ecological conditions to exist. Similarly, the vegetation, the food crops, they also need a certain set of temperature, humidity, moisture, light, these conditions. And when there are abrupt changes, then their growth and their productivity also suffers. And the United Nations believes the global food crisis is being complicated by many other factors, also climate change. And then the storms, whether we call it hurricanes or the storms, they're also becoming more frequent, more powerful, and more destructive around the world. And wildfires. Now, 10 years ago, for example, when we were looking on the implication of climate change, the wildfires were a scenario in Australia and in North America. But for the last 5-6 years, now Europe is also suffering from wildfires every year. The Mediterranean and southern European countries like Portugal, Spain, Greece, and even Turkey, they are facing huge wildfires every year. And they are becoming more and more powerful and destructive, and it is said to be a new norm. And actually, last summer, in the last July, I saw public parks and woodlands in and around London in smoke. And this was something unimaginable completely, because for the last about 8 weeks, there was no rain at all, and everything had become just a perfect fuel for any fire to be ignited. Now, if in Middle European countries like United Kingdom, I think it's a by all standards for environmentalists, it's a very, very serious wake-up call. And then there are droughts. You know, we have about 80%, 71% of our planet is covered by water, but less than 2.5% of that is actually suitable for human consumption. And even those very limited freshwater or sweetwater resources, they are depleting very, very fast. And, you know, we can live without electricity, we can live without gas, but we cannot live without water. And then there's deforestation, which is another huge challenge. And I think, again, we in Pakistan can better understand what is happening with the forests in our country. You look at our own very towns and villages and how we have killed the plantation. And if some of us are frequent visitors to northern areas, then you see, if, for example, you have been going there for the last 20 years, 30 years, you see the patterns, how the mountains and upon mountains, they have been deforested. And thanks to very powerful land and timber mafias, besides the property and the real estate culture that we have seen. Everybody is after destroying agriculture and vegetation land and building up societies and farmhouses. Here is, for example, an evidence of the threats to freshwater resources. This is Lake Chad, which is the lifeline for 4 or 5 different African countries, including Cameroon, Nigeria, Chad. This is image from 1963, and this is 1972, this is 1987, and this is 2001. Clearly, it is less than 10% of what it used to be. I have some friends from Nigeria, and they say, for example, a friend of mine, he says, his father says, their house was on the bank, on the edge of Lake Chad, and now Lake Chad is about 30 kilometers away from their house. So this is what has happened in the life of my friend's father. Now, you may say, oh, Dr. Asif is trying to scare us because he comes from the environment and climate change background, and he's just trying to create a havoc. No, that's not the case. I hope we all know this gentleman, who is said to be the biggest scientist since Einstein, Stephen Hawking. He had nothing to do with climate change. He was a physicist. He was into mathematics and astronomy. But look at what he ended up saying. We are closing the tipping point where global warming becomes irreversible if it has not been the case. And actions could push the Earth over the brink to become like Venus with a temperature of 250 degrees Celsius, raining sulfuric acid. Climate change is one of the great dangers we face, and it's one we can prevent. And look, Noam Chomsky, the living legend, the most respectable political scientist of our age, and he is not from energy and climate change background. And look what he's saying: climate change and nuclear war are the most dangerous threats to the human species. And a few years ago, they surveyed 50 Nobel laureates, and you know there is no Nobel Prize for environment. Nobel Prizes are on physics, chemistry, economics, literature, peace, and even they were asked the biggest threat facing the mankind, and they said it is climate change, ahead of issues like poverty, disease, nuclear war, and even terrorism. Now, what is to do with energy and energy transition? Well, nearly 3/4 of the greenhouse gas emissions, they're associated with the energy sector. So for that reason, we need to focus on energy sector. And for that reason, the United Nations is asking the world to move to zero carbon scenario by 2050. Means our energy systems in be carbon neutral. Now, in response to that, US says the existing regime, we don't know what will be the case, because the previous President Trump had pulled US out of Paris Agreement, and we don't know what happens in few months' time. But at least the present regime says we shall do that. The European Union says they will do that. UK says they will do that. China says they will do that. Even the oil-rich nation, Saudi Arabia, says they will do that by 2060. India says by 2070. So it means the major economies and economic blocs of the world, they're agreeing to carbon neutrality by 2050. Now, what are the main dimensions of this energy transition? The first one is decarbonization. Then it is distributed or decentralized generation. Then it is digitalization, which is the main focus of my talk. And then it is decreasing use of energy through energy conservation and management. When we talk of decarbonization, it can come through renewables like solar, wind, biomass, through hydrogen and fuel cells, through electric mobility, decarbonization in the fossil fuel sector itself, for example, through carbon capture and storage, and then phasing out or phasing down of fossil fuels. And finally, nuclear fusion, which is still in the lab phase. It is far from technical maturity. Now, renewables, when we look at, which is our biggest count for the energy transition. It has some strengths, like it has infinite resources because the sun is there for 5 billion years and it can go on for another 5 billion years. Renewable resources are widely distributed. Unlike fossil fuels, they are environmentally friendly and their cost is reducing, unlike fossil fuels. And they are also being supported by the technology and policy advancements. However, they are intermittent. Sun is available only during the daytime and not in the evening. And even there can be monsoon days and weeks. And the other problem with the renewables is they're capital intensive. Their capex is very, very high because they do not consume any fuel, so their running cost is low. Now, to support the renewables, we need to have energy storage to address their intermittency. Now, thankfully, the batteries, they have seen huge advancements in recent years. And now we can see hundreds of megawatt scale battery projects in the world. And then the carbon capture and storage is also something that especially the fossil fuel rich regions and companies, they are trying actively. However, this technology still faces techno-economic viability challenges. Then we have nuclear fusion, which is, as I said earlier, in the very, very early stages of lab development. And we don't know how long it is going to take. But since the fuel for nuclear fusion is hydrogen, which is the most abundant element in nature, though it doesn't come independently, but still. So if there's a breakthrough in nuclear fusion, it will truly be a game changer. We are living in an age of electric mobility, which is in the form of electric bikes, the electric scooters, the kids are driving around, electric cars, electric trains, and now even there are electric planes and electric ships. And then we have decentralized generation. The world is moving from centralized power plants to decentralized power plants. And there's no way to reach out to those 1 billion people who do not have access to electricity, or 3 billion people who do not have access to modern cooking fuels. The only way is distributed generation. Now, when we are going to distributed generation, already, demand and supply is a huge challenge for utilities. When there is only one centralized generation resource. But imagine when there are thousands of generation resources, and even those who are counting on the climatic conditions, the weather, it's an immense challenge. The demand and supply become a huge challenge. And there's no way to control and manage that humanly. It only needs very, very sophisticated and advanced digital technologies, which we shall see in coming slides. So this brings us to digitalization. Now, digitalization, some vivid examples in front of us are smart grids and smart meters, which are producing an awful lot of data. For example, imagine if there is a smart meter in the building that you are sitting in, it will be creating thousands of data points every day. And a good smart meter can record, for example, if you have in your building, you have 1,000 devices, including the computers and the laptops and the air conditioners and whatever. A smart meter would record every activity, what time a certain computer was switched on and what time it switched off, what time the lights in a particular room were switched on and what time switched off. So imagine if your building is going to create thousands of data points, and if a whole city and if a whole country is covered by smart grids, how many trillions of data points it's going to create every day. Now, those huge data sets, they need to be stored safely, and no human can look into those data points. you need sophisticated and very, very intelligent technology to do that, to do the data analytics through AI and machine learning, and who knows what new terminologies and avenues we shall see in coming future. And then you need robotics, then you need blockchain, and now we are living in an age of cybersecurity. While we are trying to digitalize and we are working on our IT sector to benefit the human race, there are also certain people who are using it for their vested interests, and cyber attacks and hacking has become a prolific business for certain people. And the energy sector and the utilities, they have become one of the prime targets. And even major utilities across Europe and North America, they are being hacked, they are being targeted by the cyber attacks. And in many cases, they have no choice but to surrender and meet the ransom and demands of the cyber attacks. And the irony is, in most of the cases, it doesn't go public because they do not want to shatter the confidence of their stakeholders, shareholders. So we don't know in many cases the exact nature of the cyber attack and the cost of it. And we see the robotics in the energy sector, in the renewable sector, they are playing a very important role. And if some of you can recall, about 10 years ago, there was an oil spill in one of the British Petroleum's oil rig in the Gulf of Mexico. And it was 10 kilometer, it was an off-grid oil rig, 10 kilometer below the level of sea. And no human, no technology is capable of going that deep. So what they had to do, they had to develop very, very sophisticated and specialized robots which went down to fix the problem. And it took them about 40 days, and it cost British Petroleum tens of billions of dollars in compensation. And we see drones, they are being used for asset management in solar systems, solar farms, and also for the asset maintenance. And similarly, in case of wind farms and wind turbines. And here's an overview of the range of technologies which are being used in the energy sector, from the manufacturing and production stage to generation and operation and maintenance, transmission, distribution, and utilization. And these include sensors, smart meters, smart grids, robotics, 3D printing, data analytics, IoT, AI, machine learning, digital twin, blockchain, cloud computing, and cybersecurity, to name a few. And here's a very interesting figure that shows the evolution of energy meter, the electricity meters, starting from the physical connections and analog display, and now we have moved on in terms of the functionality and in terms of accuracy. So it's a huge leap that we have made in the last 10 to 15 years. And here's an overview how the big data analytics and framework is helping the energy sector in terms of resources, wind, solar, biomass, hydropower, in terms of failure event analysis, maintenance and management, forecasting, asset condition monitoring, and these are the end users. And here's the integration of smart meters. And as I said earlier, in the age of renewable energy and distributed generation, the smart meters and smart grids, they become imperative part of the electric networks. And here's an example of 3D printing in the energy sector, for example. Here we have traditional, for example, we are talking about construction of a power plant. The traditional route is there's, for example, concrete mixing, building the blocks, there's labor involved, there's machinery and tools involved that give you the building. And the 3D printing, it overtakes, it bypasses all these stages, and it's just a one-point solution which gives you reduced weight, waste, reduced energy consumption, reduced carbon footprint, and with economy. And here's an overview of how energy efficiency is going to be helped by digitalization. And here we have seen the improvement in energy intensity that we can see over the next 22 years, and it is huge. In some cases, it is about 50% improvement in energy efficiency. Here is an overview of how the AI market is going to help in terms of market size, just the renewable energy. So here we are now, for example, the AI market in the renewable sector is about $13 billion, and in next 7 years, it's going to become nearly $80 billion. However, it all comes with a set of challenges. What are they? The cost. Digital technologies, in many cases, they are very expensive. Then they have disruptive impact, means they are challenging the existing business model, the networks, which are not often appreciated, and there's always a resistance from the existing businesses and the corporates, the policies. Then there's the issue of cybersecurity, as I have touched upon before. Compatibility in digital technologies are not always compatible. I give you an example. 3-4 years ago, we all suffered from COVID. And you would have seen, for example, in my case, I had a MacBook and I had an iPad, which I bought maybe 2013-14. But when the COVID came and we needed to go online in teaching, neither my MacBook nor the iPad were compatible with the Zoom or Microsoft Teams. So this is what is unfortunate trend in the corporate sector. You buy a particular device and 5 years later, the same company is not offering you the And then there's a lack of skilled workforce to deal with the sophisticated digital technology, and also the understanding and the comprehension and the appreciation with regards to digital technologies. So with that, I conclude, climate change is globally integrated challenge, and the world is witnessing the third energy transition, which is also called zero carbon or sustainable energy transition. And this energy transition has 4 main dimensions: decarbonization, decentralization, digitalization, and decreasing use of energy. And digital technologies are critical in enabling this energy transition. And some of the important digital technologies are sensors, building information modeling, building management systems, smart meters and smart grids, 3D or additive manufacturing, robotics, data analytics, IoT, machine learning, AI, digital twin, blockchain, and cybersecurity. In the energy transition, it requires a dynamic technology policy partnership. And finally, the planet, a global village, has a shared future for the developed and developing nations together. So with that, here are some of my recent books, The 4 Ds of Energy Transition, which I also mentioned as the 4 main dimensions of energy transition: decarbonization, decentralization, decreasing use, and digitalization. It was published in 2022. Then the Handbook of Energy Transition, the Handbook of Energy Security, and this is my new book, which will be in market next month, Handbook of Energy and Environment in the 21st Century. In case someone needs to consult these reference books. And with that, I thank you very much for your time and for inviting me to this excellent forum.
Thank you, Dr. Sir, for the informative session. And I would like to ask our audience that is there any question.
Thank you very much for a wonderful talk. You talked about the decisions made by some of the larger economies for achieving the carbon neutral status in the next 30-40 years. Is there any plan that you are aware about Pakistan? Do they have any policy? They do have a renewable energy policy, but that is by 2030 they want to integrate about 50% renewable energy and extend to 60% by 2050. But are we planning anything on carbon neutrality in Pakistan?
Sorry, I didn't get the question. Can anybody repeat the question?
You are not getting my voice, or
sorry, I can't hear it clearly. Can you please, the moderator, if you can write in the chat box?
Can you hear me?
Or maybe if you can be close to the, to the mic.
Can you hear now?
Yes, better.
Okay, so the question is, you have talked about the carbon neutral approaches, achieving carbon neutrality by some of the larger economies. Are you familiar with any such plan in Pakistan? Or do they have any carbon neutrality plan here? They do have a renewable energy policy for integrating 30% by 2030 and 60% by 2050.
I think, if I understand correctly, you have asked me about the carbon neutrality, if there is anything happening in Pakistan, any initiatives. Is that right?
Yes.
Well, okay. Just allow me to share something else. Let me please stop sharing and I'll share another file. Let me see. Okay. This another file I've shared. I hope you can see. Now, here's my book on energy crisis in Pakistan, which I wrote in 2011. It was published by Oxford University Press, and I wrote it when I was in Glasgow. And you can imagine how big a challenge it would be for somebody to sit outside and to gather all the information and data and stats. And remember, it was not Zoom or WhatsApp and so on. And I've been writing in Dawn and the News since 2005 on the energy issues in Pakistan. And I think our energy problems and our energy issues and our energy crisis is self-created, which is very well managed, which is being beautifully fostered, and which is being beautifully propagated. It's only issue of management, and I don't see any point when, on one hand, we are bringing, for example, electric buses, as 50 electric buses, and on the other hand, we are setting up 3 new coal power plants. So I wish if we had time to discuss the issues which are really plaguing the Pakistan's energy sector in more detail, but I'm not here to give you only bad news, but I have given up. I have given up writing in newspapers. I have given up writing because unless there is a divine intervention, as long as it is in the hands of our capable policy and decision makers, I don't see any light at the end of the tunnel, unfortunately. Although, yes, renewable energy is now there and wind power projects, but considering the scale of challenges that we face and the kind of discrepancies, there are still 4 or 5 times more fossil fuel power plants which are being set up compared to renewable power plants. So we have these kind of discrepancies. How can we say, how we can say that the positives are dominant compared to the negatives?
Yes, correct. I agree. Okay. So there is another question.
Assalamu alaikum, Dr. Asif. This is Dr. Nayyar Hussain. I have been following your. Can you hear me now?
Yes.
This is Dr. Nayyar. I have been following your articles in newspapers. Even have been through this book, Crisis of Pakistan, word by word, and just had a presentation on energy transition over this forum. You have rightly responded to just a question from Dr. Fakar right now. So we have governance and management issues. But looking at your presentation, which pertains digitization. So this is not only for RE. What you would say, how come we equip our younger generation with IT, AI, and other tools without major cost investments such that they become capable, and the day we are somewhere in achieving energy transition, we can implement one of the most important Ds of energy transition, which is digitization. Because cost and financial stability is our major constraint. So how come without major cost investment and financial support from the government, we can somehow implement, as otherwise round we implement from the neighboring countries? They lead in major AI and Google and other organizations. What ideas you can suggest for this forum? Thank you.
Well, please excuse me. I cannot gather because of the sound issue. I know you are talking very clearly, but I have not really gathered the question. Can the moderator please just write the gist of it, and I'll try to answer.
यहाँ पे आके बोलते हैं, यहाँ से बात।
It's just the technology issue. Nothing wrong with your question or with your expression.
Can you hear me?
Yes.
Okay, thank you. So I was surprising and seeking your guidance on how digitization without cost hurdle or constraint we can implement and equip our generation, because cost is major issue and financial viability we have been lacking. So how come we can implement digitization? Someday we need to equip our generation with AI and other digitization tools without major investment, maybe through curriculum development or other suggestions you may have.
Well, I think in a country like Pakistan, as I said, and I have to be very honest, that our energy problem, our energy crisis is a self-created and very beautifully and very carefully self-managed. Probably there's nothing better we have done in the last 20 years than managing and caring and protecting our energy crisis. And 20 years ago, if you talk of the corruption, what comes to your mind? The first thing, meter readers, WAPDA, besides some of the other institutions. Now we need to automate. We need to, and unfortunately, over the years, the corruption component has only increased in our society, and we need to minimize the human influence in our energy systems as much as possible through technology. And for example, in case of, in some parts of country, 70% of the electricity is not paid for. And the thefts, reported thefts in some discos are close to 40%. And how can a utility, how can a country's energy sector can survive with this high losses? So probably an appropriate way to do that is to automate the system, and the technologies are available. For example, prepaid metering it has been used worldwide to address the issue of losses and thefts. And similarly, the smart meter, the smart grids, and there are so many technologies now available to detect the losses and thefts. And this is something which is very, very important to do in our power sector, in our energy sector. And the same is the case with the gas. Imagine the losses over there. So there's a lot that the automation, the digitalization can offer to our energy sector. And probably there will be fewer societies more needful of these technologies than Pakistan. We seriously need to dehumanize our energy sector to control the losses. I hope I have answered your question if I understood it correctly.
Any other question from? Okay, so thank you, Dr. Saab, and it was a very useful session for us. And now we move towards the next presentation. Thank you very much for.
Thank you, Leia.
Our next talk is Reclaiming the Energy from Waste, a study of using waste cooking oil to biodiesel, and it will be presented by Dr. Nadeem Ahmed Sheikh. Let me introduce you Dr. Nadeem Ahmed Sheikh. Dr. Nadeem Ahmed Sheikh is serving as a professor in the Department of Mechanical Engineering at International Islamic University and currently have the portfolio of Dean of Faculty of Engineering and Technology. He has started 2 BS and 3 graduate programs in the faculty with diverse multidisciplinary approach, especially in biomedical and energy engineering. In addition, he was visiting professor in Aston and Teesside universities in UK. He is author of more than 100 impact factor journals of high international repute. His combined impact factor is more than 250. His key areas of research and development is low-cost, eco-friendly energy technologies and related power systems with focus on circularity, waste-to-fuel technologies and conversion efficiencies. In addition, he is interested in building energy modeling with the context of recent advancement of AI, IoT and areas of interest for optimization, thermal projection and forecasting. He has been honored with Presidential Gold Medal for securing position at Bachelor's in Mechanical Engineering. In addition, he has been granted prestigious King Abdullah Postdoctoral Fellowship at cost KSA for a period of 1 year. Moreover, he is an honorary visiting research fellow of Sustainable Development Policy Institute and also a member of National Committee on Energy Transition. He is co-founder and mentor of several companies and startups including Plastofuels, Circular Energies Private Limited, WeClean Private Limited, Carbon Queen, and Eco Research Limited. His major roles include mentorship, technical support, financial advice, and technology readiness with particular focus on pyrolysis, gasification, biodiesel, and related thermochemical upscaling. Please welcome Dr. Nadeem Ahmed Sheikh to present his talk.
Assalamu alaikum. Thank you very much for this general introduction. I'm Nadeem Ahmed Sheikh from International Islamic University, and I'm the professor of mechanical engineering, and my key areas which I'm going to talk about in a bit is about energy, how we can transit from the waste energy, waste materials to a more sustainable future. So I'll move to the next slide. This is the brief outline of the talk I'm going to talk about. Okay, before moving towards my presentation, a quick overlook at what I am doing. Basically, like she introduced me, I'm more into the data-driven modeling for the multi-objective optimization for different systems, particularly focusing on the thermal systems in detail, which includes the building as well as the energy sector. I'm working at HVAC sector, and for the last half a decade, I've worked at the biofuels and how we can have a sustainable fuel generation mechanism, whether for the hydrogen production or today's talk is about the renewable diesel. So I hope that would be something which will be a new thing, a thing which is of interest for many people here. So this is some of the clients I'm working already with, different agencies, government sector agencies. I'm working with CDA, with WAPDA, with Pak Railways, and some of the private sector firms as well. Coldcraft, which is a famous firm in Lahore, and in the IT solutions, I'm working with the Micromerger, and in the plastics industry, I'm working with the Axel World Private Limited. It is in Faisalabad, and then some of the startups which I've started. WeClean is a company which is working on waste collection, and they're using different digital technologies for waste segregation processes. SIT is my new startup, which just launched that last week. That is Smart Integrated Technologies, which is using different IoT platforms and machine learning for process improvement and optimization of the processes. At the bottom there is Carbon Queen. There's a queen at the bottom, which is basically a carbon accounting startup which I have started last year. And CEPL is Circular Energies Private Limited, which is again a company which is in collaboration with the Eco Research at the top, which is a British company. We're working together for pyrolysis and gasification, and Plastofuel is also a pyrolysis and gasification startup. So these are different startups, and in the middle there are startups which I have started. There are 5 of them, and there are different sectors of economy and people we are working with, different companies and agencies. And some of our projects have won awards as well. Prestigious HULT Prize. We won that last year for making or using the plastic waste to 3D printing material. That was the startup which was awarded by the HULT Prize out of 250,000 different startups across the globe. We are working with NCGSA, which is a funding agency, working with the WAPDA to measure and power some of their underground pumping stations. And on the left you can see the thing which I'm going to talk about is the renewable or the biofuel, which is called the renewable diesel. So there's a lot of the previous talk just happened to learn and get some of the ideas from the digitalization they are doing, and the ideas we're presenting about how we can move towards a sustainable future where we can have a net zero approach. And there is not a single bullet, silver bullet we can take and that, okay, that is the bullet and we take that and we get to that sustainable future. We have to move incrementally and in different scopes and different areas and make incremental steps towards that. So definitely we know that we can go for net zero building in future, and maybe in 10 years time we can get a net zero building at the domestic sector or maybe in the commercial sector. But there are already millions of buildings existing in this planet, and how we go about them, how carbon neutral they would become. So that is one challenge, for example. So we can install solar, wind plants, and we can convert some of the ideas from fossil fuel to renewable fuels by transitioning towards the solar and PV and other ideas. So here are some of the ideas which I have shortlisted. So biofuels is definitely one idea. There is definitely ways of improving the design architecture of the buildings, and as well as we can move towards a more digitalized system where we can have a robust control so that the whole of the building, whole of the sector is somehow transformed to a renewable idea. But there are certain challenges which are definitely in the way. Okay, the challenges, they are very, very stark. For example, the storage is one big challenge, whether it is electric storage or whether it is the thermal storage we're talking about. And they're not reliable, and they can't be robust enough so that we can rely and put our whole base load onto it. So that is one of the biggest challenge we have. So on the right hand side, on your right, you can see some of the initiatives we have taken in our labs. So storing, these are some of the conventional technologies as well as some of the non-conventional technologies. But one big challenge we have is the low density of these of the available availability of the energy we have. In 1 liter of petrol or diesel, you have a lot of energy. But if you want to replica or get the same amount of energy from the solar, you have to have a very large footprint on the land to get the same amount of energy from that. So that is one big challenge we have. And plus, on top of that, there are different cultural and social challenges we have. For example, there's a lot of talk about just transition, so that it is not only, so in terms of the emitter of the CO2 into the atmosphere, Pakistan is not the biggest emitter. In fact, we are not in the top 10. In fact, we are not in the top 50 even. So we pay the price of those countries, for example China, for example Britain, for example US, who have consumed a lot of energy to get the wealth, the prosperity, and now somebody is coming and telling me that, okay, you can't use diesel engine, you can't use CO2 emissions from the coal-fired power plant, you have to move towards the renewable, and which is damn expensive and damn difficult to run. So there is definitely a challenge, which is a social challenge as well, we have in terms of the transforming to the renewables. So this comes with the other side of the talk. The other side of the talk is definitely looking at the pathways, at the bioeconomy we have. Bioeconomy is a new booming idea that a lot of energy is available in the plants and in the other forms of the organisms which are available in the planet, and people are trying to harvest that into different kind of ideas of generating the heat or the fuel from those sources. So some of the products which are listed there is the biodiesel, alcohols. There are some of the drugs which are being formed in terms of the materials that can be used for energy storage, and then we can generate heat and electricity from by burning them directly. So, and there are different platforms and technological ways are available that how we can transform those waste into useful products. So those pathways, they have a number of challenges, whether they are in terms of the CO2 emission or whether they are from the perspective of the economics. One of the biggest factor is the economics. So when we talk about whether we want to transform ourselves, so then the $1 billion question comes out, that where the $1 billion will be coming from. That if you ask me to run the electricity power plant on a different fuel, that who will be putting that much of money so that we can get to a net zero goal. So all of these pathways, they have a certain carbon footprint, and those carbon footprints are critical in terms of their evaluation and estimation. So my talk is about the life cycle assessment, that how we are doing something and how much effect that is going to cause onto the environment, onto the people, onto the surrounding we are living in. So here are some quick facts. So we can see that on this slide, the biggest thing which is coming out is the biofuels. And you know that for the fact that around last year, 1,700 billion liters of diesel were used globally. 1,700 billion. And out of that, 200 billion liters were biofuels. So that is a tiny portion of it, like around 10 or maybe 10% or less than that. But we know that for the fact that the biodiesel or the renewable diesel is the second most used and produced biofuel globally. I mean, this only in US, it is one of the largest biofuel which has been made. We talk about the Latin American, they are producing bioalcohol there. That is, a lot of crops are used for that. So then there's a debate which comes from that, whether we are growing crops for feeding our people and animal, or feeding our cars and the power plants. So there's a huge discussion going on that what is the cost effect of that whole thing. But there's another fun fact which I would like to share here. The food we eat and the amount of food we waste, the oil which is coming whether from the kitchen producing the grey water, that grey water is purely a drinking water we are using on the globe, and 1 liter of the cooking oil, when it is wasted, it ends up creating 25% of the global pollution in the water. That is a huge amount of thing. Now, why is it linked with it? Let's look at that. So here is one case study which I'm trying to highlight here. There's a casino in Minnesota. In 2007, in that casino, they used the waste cooking oil from their 9 restaurants, and they produced around 1,000 gallons of biodiesel from there. So that technology was available in 2007 where people were using the waste cooking oil for making biodiesel. Now, what is that kind of idea, and how is it important, and how we can learn from there? For example, Pakistan last year imported around 3.5 billion US dollar worth of diesel. And out of that, 25% is consumed in the agriculture sector. Agriculture sector is one of the largest consumer of diesel in Pakistan, whether you're pumping water from the underground reservoir or you are powering your tractors for threshing and other purposes. On top of that, we imported about 3.8 billion US dollars worth of cooking oil. We don't produce cooking oil in that amount that we consume. And Pakistan is amongst the top 2 nations in terms of the consumption of the second. We are on the number 2 in terms of consumption of the cooking oil. Now, who is the first one? India. After India, we are the biggest country consuming the largest amount of cooking oil. And from where we are importing it, we are mostly importing it from Malaysia, Indonesia, from those countries where palm trees are available, from where the palm oil is available. So we are putting a huge amount of money to import 2 different oils, and we are not linking them together in a link. So how it works? So it starts from the crops, from the photosynthesis, and then goes to the vegetable oil generation, and then we get the refined vegetable oil. There are 2 pathways from here. From using the vegetable oil, we can directly go to a process called a trans-esterification to produce alcohol, and use alcohol to produce biodiesel. Now, this is a biodiesel which is formed purely from the crop. Or we can use this refined vegetable oil and use it in our homes and kitchens and make it waste when we're going to throw it away. Remember, during the winter we ate a lot of fish, and it produced a lot of black oil which is left. And into the bin, into the drain, and it ends up costing us a lot, because it is going to cause this water pollution, which is humongous. We just learned that 1 liter of waste cooking oil can waste up to 25,000 liters of water. So that's a huge amount of water it is going to waste. So biodiesel, it can come up from the refined pure virgin oil, or it can come from the waste cooking oil which is already burnt and it has no physical or of nutrient appeal for us. Okay, so how it looks like from the engineering perspective, this is the whole way of doing it. The process which is at the center of this whole thing is the trans-esterification, and it consumes the animal fat. It can come as a dead animal fat, or as a waste cooking oil, or a virgin vegetable or fat that can come, and that can be converted into very useful products. They can be biodiesel that can be formed, and then we can have glycerin, which is one of the beauty products we use. These are 2 byproducts that are coming from the waste we are producing. And in terms of the emissions, which is big talk these days, so if we compare now these numbers at the bottom, B2, B5, B20, and B100, this is biodiesel. when it is blended with the normal diesel. If 2% of the biodiesel is blended with 98% of the mineral diesel, it is called B2. And if it is 100% biodiesel, none of the mineral diesel is consumed in terms of blending, it is B100. So if we see that for a single liter of burning of same amount of diesel, mineral diesel compared to the biodiesel, there is a drastic difference of the emissions of the CO2. So here we are talking about like 88 tons of CO2, and then at the last we are looking at around 19 tons of CO2 being emitted. So definitely by consuming and using the sustainable or renewable diesel, we can definitely move to a lesser CO2 emission paradigm. And for the fun fact, there's a fun fact for everybody that the diesel engine, when it was first originally made, it was made for the vegetable oil. It was designed for the vegetable oil, but later on some of the people they discovered the mineral oil coming at a very cheaper cost in Middle East, so they turned it and tuned it according for that diesel. So originally the diesel engine is designed for the vegetable oil. And definitely this renewable diesel can be used in any type of purpose, from generators to railway transportation, steamships. Now that is something which is very important. You know that around 3% of the global emissions they're coming from the sea transport. And there's a huge question going on, what sort of new fuel they should be using for burning their engines to run them. And we are at a very critical juncture because they have to make a decision. And there are top 3 contenders there. One is hydrogen, which is a very difficult fuel to handle with, because everybody knows that it is a very potent fuel, but it has a lot of limitations. The other is ammonia, which is otherwise very toxic, because ammonia is a very toxic fuel, but it is, in terms of transportation, it's a good fuel to work with. Already people are using it in different industries in refinery and other places, ammonia is used. And the third fuel in this list is the biodiesel or the renewable diesel we're talking about. So this is one good place. Trucks, again, the trucks are the rickshaws of the economy. They run the economy because they transport goods, and all fast-moving goods are basically carried out from trucks. Aircrafts, around 2% emissions globally. Boilers, we are using that in industry. Then in domestic cars and transport and agriculture. So we can use this anywhere, literally anywhere. The same way we are using the diesel, we can switch to biodiesel. So challenges. I've talked about how good the biodiesel can be, how good the sustainable diesel can be. But definitely when we talk about in terms of comparison of the calorific value. Calorific value is that how much of energy it contains in 1 kilogram or 1 liter. And if you see that, B0 is like that diesel which is coming out from the earth, from the fossil fuel. That's around 42 megajoules per kilogram. And if we talk about 100% biodiesel, that is about 38 or 35.8 megajoules per kilogram. So there's a slight difference, around 7 to 8% decrease in the energy concentration. But compare it with the solar. In terms of energy density, that's still a very large number, a huge number, because in terms of getting the same amount of energy from solar, you have to have a larger piece of land to work with. And there's other challenges in terms of the logistics, how we can collect the waste cooking oil from domestic, from all domestic locations, from hotels, from industry, and take it to a certain place where we can convert that into a more sustainable diesel. And then lastly, what is the most important thing and mentioned in the last presentation as well, is about the governmental support and the policy that has to be in place that makes sure that the restaurants are following the regulatory framework. Because when I started this startup, I went to the local tailors and other places to pick up the oil. And when I asked them that where do you throw your oil, there's no waste. We keep on adding more and more oil in it, more and more ghee in it, and it continuously works. So they're not really concerned about the health of ordinary people. because if you burn the oil for 2 or 3 times, then afterwards it is hydrogenated and it is of no longer use, and it is actually bad for the health, not good for the health. But because nobody is taking care of that from the food department or from other departments of the government, so they don't really put that into account. But in the larger hotels, for example, working with the Serena Hotel, they were very forthcoming, and they provided us their waste cooking oil. So they were producing like 50 liters per day. So they offered us to take it free, and we offered them to take the diesel for free, because if we convert that, there's only a tiny amount of cost which is involved. So we covered that from the ICECE funding. So that was the success story that built us to take us to the next step of getting it to the commercial level. So this is the success story. So we took Serena's hotel cooking oil, and how would we take that from Serena Hotel and bring it to International Islamic University? There was like 25 kilometers of distance between them. So we talked to one of our industrial partner, We Clean Private Limited, and they helped us doing the logistics, bringing that oil, daily oil from the hotel, bringing it to our labs. We did the initial screening, and then we built the first pilot plant of 50 liters. So we would convert 50 liters of biodiesel every day into diesel, and we would give it back to We Clean, and they would take it to different customers. They can take it back to Serena. There's no obligation for Serena to take it back in terms of using it. So they said that you can sell it to other people as well. So we sold them to different agro farms, and one of the farm in Sawabi in KPK, they were so much interested. They ran all of their tractors and trolleys on the diesel, and we sold this diesel at 100 rupees per liter. So in the market is around like 280 rupees per liter at the moment, and they were so happy. They are still calling me that, okay, we need more and more, because we are doing more construction work and we're doing more drilling work, so we need more diesel for that kind of applications. And the byproduct is more interesting. We produce glycerol, which is top chemical, very sought after chemical for soap industry. For all soap makers, for all shampoos and other detergents and cream makers, they're really interested in this glycerol, which is a very refined product coming out from this. So we started with the lab work. On the top you can see the lab where we can separate the wax or the glycerol from the diesel, and at the bottom is the plant we used, and up till now we have produced more than 6,000 liters of biodiesel, and that's all done in the university. So and it's only one source. Mainly we relied on Serena Hotel. They provided us every day with 50 liters of oil, but we experimented a lot as well, and we tried other things as well, and we ran from this biodiesel, we ran different engines and different places. We got the success story. Next, our plan is, because now we're transforming it as a startup. Just I mentioned in the start that we have just launched that startup. So with the help of We Clean, we are trying to build a 1,000-liter facility, and we are talking to other suppliers so that we can, at the end of the day, what we are giving them back is that we're giving them a certificate that their process is becoming carbon neutral in terms of emissions, and we are calculating how much of CO2 emissions they are saving by just giving and converting this whole process into a sustainable diesel enterprise. So they get at the end of the day an award, and they can cash that in the European market in terms of the CO2 budget they are getting. So what is important, and the whole thing which I brought into this talk and discussion is about, this is not a novel idea, this is not a new idea. People are already using it. And what we have tried here in Pakistan in the last 1 or 2 years, that we tried to bridge the gap and fill all the holes and link those people who are relevant and making this happen. So what we realize is that there's a lot of potential in the waste. And there is a very low-hanging fruit which is available, which is leading us towards a sustainable, more robust and more reliable future, which we want actually. So what we did, that let's do a wholesome analysis rather than looking at one piece of the thing. I mean, when we talk about diesel, people are usually thinking that it is a lot of emissions are coming. One of the main polluters is diesel. That's our thinking at the back of our heads. But when we think from the perspective that if we are making it sustainable, if we are making it renewable, then how come it is the biggest polluter? Even if you buy renewable solar energy, the end of shelf life of that solar panel, how it is produced, how rare earth materials are mined, there's still a lot of carbon budget going there, and it is going to consume a lot of energy, which is going to come from that same emission factor we are talking about. So when we look at the wholesome picture, there is a kind of analysis we do which is called the life cycle analysis. Now the life cycle analysis talks about taking it from the cradle and ending it at the grave. That how thing is cradled and eventually went back or go back to the grave. So that kind of analysis is more wholesome, and it includes all the perspective we are talking about. So we took this process and we looked at the different ingredients of this process. So starting from the collection of the raw waste, and then transportation of that raw material, then treatment, then acidification, and distribution, and then eventually the combustion of that. So let's look at what factors are contributing towards this this whole paradigm. And when we looked at these inputs and outputs, if you can look at this whole figure, so there are several inputs into the system and there are few outputs we are coming out from this. So definitely there is wastewater which is coming out from here. That is something which is very important, and we'll talk about that later. Definitely there is emissions coming out. I talked about that in comparison to the diesel we are using. It is far less. Then glycerol is coming, which is a very useful product. But what is going inside is very important. This is electricity which is going in. Again, if this electricity is coming from the renewable sector, this process can become more renewable in terms of its less emissions. But if this is coming from maybe a coal-fired power plant, definitely it would have a different perspective. Okay, let's look at this figure in more detail. So this is the top, which is the boundary of the life cycle analysis, and then at the bottom we have, I don't know if you can see that, is the environmental life cycle analysis, which is definitely from the perspective of how much emissions it is causing, how much of human health it is going to disturb, and how much of resources it is going to use. But there is another perspective which is far more important and leading us towards the just transition. It is the social impact. How much of women empowerment it is going to create? How much of new jobs it is going to create? Is it a place where people can invest and find revenues? So maybe it can be a small and medium enterprise which it can generate. So it can create more opportunities for people to, and again, the biggest thing is that unless there is economics involved with some intervention, people are not going to be interested in there. So this is what happened in the solar industry. When the cost came down, the economics become reasonable. Only then people went into this investment. Otherwise, nobody would have gone into this. So again, this whole analysis is now comprehensive in terms of not only looking at the environmental impact, but also looking at the social impact, that whether it is acceptable, whether it is going to cause any impact onto the women empowerment or forced labor or child labor or some economic development or some gender equality. That kind of analysis is also important. So, like I mentioned, we started with Serena Hotel for this analysis, but we also used different other approaches, which include some local oil for frying, some local oil for chapli kebabs, which has more fat ingredient in it, and then some crude palm oil. And then one very interesting portion we hit on was the chicken feather oil. Now, this is a story which is, I don't know, if I tell that in English, it is not that amazing, but if you hear that in Punjabi, you would see that it is so disgusting. I went to that factory where people were collecting the waste of the chicken. When you slaughter the chicken and remove its inside, which is thrown away, you know that it is a very precious thing. How come? It is sold at 100 rupees per liter. You know, what is liter? Why the liter is coming here? It is taken to a place in Hattar. It is an industrial state. and they put that into a big boiler. The whole of the truck would come and empty into that boiler, and they will cook it for 3 hours and spin out the oil from there. And that oil looks very similar to the vegetable oil we use. Now remember that vegetable oil we are using is around 400 rupees per liter at the moment. And that oil is 100 rupees. And if you blend that together, you won't even smell that it is chicken oil or vegetable oil. And people are literally blending it. I went to those factories where they're blending it and selling it. And all of the hotels, the cheap dhabas, they're more interested in looking at a cheaper oil rather than buying Sufi cooking oil or Dalda cooking oil at a 500 rupees per liter. So I was amazed and shocked that how come we can play with the health of people. But again, what I tried from the perspective of as a researcher, I took that oil. Nobody was giving me a sample of that oil. They were so scared that I would take it to some government agency and I would report against them. I spoke to some of the friends and I brought some of the samples. I said, I will try to make it more useful thing, more regulatory thing from this. If I can make diesel from here, that would be more useful, and maybe you can have a different market altogether. So I use that as well, oil for my purpose. Sorry, yeah, okay, thank you. So I'll quickly go through this table. There are huge numbers there, but just to summarize this, these are the units of different analysis we have taken for the life cycle analysis, from the collection, from treatment, from the transacidification, washing of it, and use of the diesel of biodiesel in the engine. So we have taken the different factors for our life cycle analysis, and you can see that there is 3 columns on the other side: waste cooking oil, chicken feather oil, and the virgin oil, which is the palm crude oil, which is the oil we use normally, and we took equal amounts so that we can make a comparison out of them. So here are some of the indicators I'm going to talk about. The yellow one is the yellow bar is the fossil fuel diesel, which we know that is one of the biggest polluter globally. Then the amber color is the waste cooking oil. The green one, the light green one is the crude palm oil, and the chicken feather oil is the dark green one. And we can see that in terms of the global warming potential or the impact it is causing, it is about 25% lesser than what the normal diesel would be. And in terms of the ozone depletion or the fine particulate matter it is going to produce, it is about half of what diesel would be doing. What is more important for me, from my perspective, was the toxicity it is going to create in the fresh water. Now the whole process involves washing the diesel with water, and we use certain chemicals in that. So what happens that when we wash it, the chemical will enter into the water system, and that would be something which is very important. So if you see that the 4th column, you see that the diesel, it is very less in terms of the freshwater toxicity, but the other types of biodiesel, they are higher. So what we are doing in terms of the research, we are changing the catalyst and making it more environmental and human-friendly catalyst that can be used to lower these emissions in terms of the freshwater emission. So and same goes with the marine ecotoxicity. Again, if you are producing water which is going to end up in the marine cycle, it is going to affect that as well. So that is something which is important for us, and that is the next part of our research, that we are moving towards a more sustainable and renewable part of the diesel, which is not only impacting the emissions, but also looking at the ecosystem and the freshwater supplies. So I think there is time for question and answer as well. So I'll stop here and I'll take to the final slide before concluding this. What is important is that there are countries across the globe. For example, if you go to Malaysia or Indonesia, they have enforced that the biodiesel has to be blended with the normal diesel. So all of the transportation, whether they're using railways or trucks or buses, they use B20 oil, which is a 20% blended biodiesel oil. So diesel with the blended 20% of the biodiesel. So, and the other perspective which I'm going to talk about, I have also talked about, is the collection of the waste. So there is no regulatory framework at the moment. There was one law which was passed by the government of Punjab in 2018. It was that they restricted all the restaurants and food processing industries that they cannot sell their waste cooked oil to anyone except the licensed agency. Now that was the act passed in 2018, and not a single license has been issued till to date. So this is 6 years down the line. There's not a single company which has a license. So when there's no company with license, they can sell it to anybody. So there is no framework of implementing that how the license could be obtained. And there has been a dispute between the food agency and the VASA that who would issue the license. And they are just fighting over it for last 6 years. And the Ministry of Law hasn't figured out that who will be giving the license. So when I applied for the license, I went to both food industry as well as to the VASA, and they told me that, okay, go and talk to the minister, and if he agrees, write it on the pad, get some note from us, and then we'll get a special approval for you. But there's no framework, there's no way that you can apply for it. So that is the biggest state of affair where we have gone very stray, and that was the discussion as well and the last talk as well, that in Pakistan it's a difficult situation to work with those agencies, but definitely with academia, industry, regulatory framework, government agencies working together, we can bridge the gap, and we can always hope that we can find a sustainable and better future. Thank you very much. Thank you for the patience for listening. Thank you.
Thank you, Dr. Nadeem. It was very interesting talk, and particularly the biodiesel concept. It's new for me as well, because I was not from this field, but it's very interesting. So one of my questions, and then we will move towards the audience for the what efforts you suggest for the awareness? Because if this is what people are aware of that technology, then of course they will come towards the adoption. So what efforts are being made from your side so that we can convince, or we can move towards some policy making for the utilization of the biodiesel?
From the personal perspective, from the university, we have tried to encourage, and we have gone to, in our locality, we have gone to almost many different restaurants and high-chain restaurants that we can offer you free of cost services. But the biggest fear they have, and that is the problem, that the quality of the ingredients people are using in their restaurants, they are substandard. For example, if they are buying, again, there is another story. When we went to Serena Hotel to buy their waste cooking oil, they told us that they give it to one contractor who end up selling it to, you know what? They end up selling it to these people who are doing the function. They are arranging functions for ye jo shadi hall hota hai. They're giving it to those people, and they're using their used cooking oil to make dishes for us during the marriage ceremony, and we eat that. And it's very tasty. So that's the problem. The quality of the ingredients we are using is, and nobody's really careful that this is against the law. And when you talk to those people, they said everybody knows, but nobody's putting any restriction on that. Then the other thing, the soap industry, they take every dead animal, whether it is roadside dead animal or anything, and they would take it to their places, and you go to their places, to the industry, they're really smelly, and they're in a very poor condition. And what are they doing? They're making Lux and soap for us. So we are using as a beauty soap and other things. And they're coming from poor quality dead animal skins. It is against the law. You have to use a certain quantity of or type of fat that can be used in the soap industry. Again, the problem is with the regulatory framework. If it is implemented, it's already there. I just told you that there is a licensing mechanism as well. It's already in the act, but nobody's implementing it. I hope that I've taken, sir.
Thank you. And is any other question?
I need to go to the other session, but very quick question for you. I think the biodiesel production was also done in Siraj here by the chemical group, but they were using some catalysts which they were very fond of. So you talked about them also. What kind of catalyst did you use? They were using some coal bone or some,
they're using a potassium hydroxide. It's a very toxic chemical. When it ends up in the waterways, it's not good. So what we are trying to do, we are moving towards NOH, COH. Although usme kuch thoda sa we need to tune things done. We have done that, and we haven't shown the result as yet because it is in another place. But we've tried to patent it as well. We've sent it for the patent as well. उससे हमें फायदा ये होगा कि we can lower the water जो इसमें जो emissions हो रही हैं in terms of toxicity वो कम की जा सकती है. That is one sustainable thing.
The other question I had was when you use them in as a percentage like B20 in regular diesel engine, do they require any kind of modification before they can use?
No. Absolutely no.
And for B100?
B100, yes. Because there is a problem that it will crystallize at a colder temperature. 5 डिग्री से कम पे ये जेल बनना शुरू होगा. इसको हल्का सा हीट करना पड़ता है.
Thank you.
Thank you very much.
Thank you, Dr. Nadeem.
I will request Dr. Abdul Rahman Kashif to present souvenir to Dr. Nadeem Ahmad Sheikh. Sir, please come forward. Is side there. Thank you, Dr. Nadeem Ahmad Sheikh. Let's move towards our last talk. Our last talk is on fossil fuels and environmental impacts, and it will be presented by Dr. Muhammad Yunus Sahid. Let me introduce you Dr. Muhammad Yunus Sahid. Dr. Muhammad Yunus Sahid is an ex-director of Environment Protection Department, Government of Punjab. He did his PhD in Environment Management, MPhil in Environmental Sciences, MSc in Applied Environmental Sciences, and 3 PhD diplomas in Environmental Laws, HSc and EMS. He is a certified master trainer in dengue control and management. He has dedicated 35 years to Environment Protection Department. He has substantial expertise in legal environmental compliances and played key roles in legislation, inspection, reporting, and implementation across various capacities. Dr. Muhammad Yunus Sahid has also contributed significantly to environmental education, delivering lectures and conducting trainings as a certified master trainer. His work spans across drafting environmental legislation, managing complaints and cases in environmental matters, and implementing innovative solutions for smoke eradication, designing stack emission control systems, and environmental improvements. Please welcome Dr. Muhammad Yunus Sahid.
Fossil fuels are the greatest source of greenhouse gases. And due to these greenhouse gases, we are facing a lot of problems. We are all consumers of environment, but none of us pays for its consumption.
Lahore, Peshawar, New Delhi are parallel to the Indo-Gangetic plains and have same environmental conditions, the same smog effects and smog density. Because the Indo-Gangetic plain, Himalayan range blocks the pollution and humidity and convert it into smog in winter season. About 60% global warming is due to carbon dioxide and 15% is due to methane and nitrous oxide. All comes from the biofuels. These are what fuel? Fossil fuels. मैं थोड़ा सा इसको कर दूं कि ये जो सूरज से हमें डायरेक्ट हीट नहीं आती, सूरज से हमें अल्ट्रावायलेट रेज आती हैं, ओजोन इसको कन्वर्ट करती है आईआर में, और ये पूरा सिस्टम हमारा आईआर पे बेस्ड है। तो सूरज से हमें डायरेक्ट हीट नहीं आती, ग्राउंड लेवल पे 58, अगर हम क्लाउड लेवल पे चले जाएं तो वो तकरीबन 0 to 5, नेशनल फ्लाइट पे चले जाएं तो 15 centigrade minus, international minus 35, and about 60 kilometer, 20 kilometer above it is minus 60, and at the altitude of 90 kilometer above it is minus 85. जितना भी ग्लोबल वार्मिंग का फिनोमेना है 6 से 7 किलोमीटर तक है, ऊपर ठंड है, सारी की सारी जो जितनी भी सारी हीट है वो 30% वापस जाना होती है, ग्रीन हाउस गैसेस उसको ट्रैप कर लेती हैं। एनवायरनमेंट इज द बिगेस्ट रिएक्टर। तो ये टेम्परेचर बेस जब एनर्जी बढ़ जाती है तो ये हमारे प्लांट जो है ना वो डायरेक्ट जिंदा में कंसिडर नहीं होते। दे आर रिस्पॉन्सिव टू क्लाइमेटिक कंडीशंस। देयर डिस्ट्रीब्यूशन is regional and seasonal is due to environmental conditions. When environmental conditions suits them, they start to grow, vegetative growth, reproductive growth. अब थोड़ा तसव्वुर करें कि अगर प्लांट को उसकी रिप्रोडक्टिव ग्रोथ की बेस लाइन ना मिले तो कभी भी उसके अंदर फ्लोरिजन नहीं पैदा होगा, फ्लावर नहीं आएंगे और उसकी यील्ड, उसको फ्रूट नहीं लगेंगे। ये एनवायरमेंटली बांझपन, इनफर्टाइल हो जाती हैं फसलें हमारी पार्शली या कंप्लीटली। सबसे ज्यादा हमारा फ्लोरा जो ना वो डिस्टर्ब हो रहा है क्योंकि हम लोग मैनेज कर सकते हैं, फ्लोरा नहीं कर सकता। You can see 85% pollution, 83% pollution in Lahore is due to fossil fuels, transport sector. 83.5 and 15 and 9% is the industries. Industries use mixed fuels, biodiesel and wood and different fuels. But transport use fossil fuels purely. It is 83.15%. Waste burning and other are very smaller. In Peshawar, you can see 85.4% smog phenomena, pollution phenomena, global warming phenomena is due to transport sector. This means we have to adopt reforms in transport sector in big cities. There is a great contribution of climatic conditions. India's Delhi, Peshawar and Lahore have same locations. Himalayan range traps humidity and pollution, and in winter season these pollutants and fog get together and become smog. लाहौर में हम only for 17 days हम अपने स्टैंडर्ड के मुताबिक एनवायरनमेंट हमें मिलता है, बाकी दिनों में हमारे एनवायरनमेंटल स्टैंडर्ड को एक्सीड करती है। ये देखिए 17 जो ग्रीन कलर है। If we consider Punjab level, then the transport contribution is 43%. When we consider only city level, Peshawar is 83%, 85%, Lahore is 83%. And if we consider whole Punjab, it is 43% contribution in smog and air pollution due to fossil fuels. Transport means fossil fuels. These are further contribution of different. ये देखिए काबल, लाहौर, न्यू दिल्ली, इस्लामाबाद का जो लोकेशन है वो एनवायरमेंटल फ्रेंडली नहीं है क्योंकि ये यू शेप में पहाड़ों के अंदर है और यहाँ पे वैली में छोटे छोटे शहर तो गुजारा हो जाता है, लेकिन बिगर सिटीज जो ना वो ये पोल्यूशन ट्रैप हो जाती है और वो ये तकरीबन इसलिए न्यू दिल्ली, लाहौर, काबल और पेशावर में हमारी कोशिशों के बावजूद भी हम कंप्लीटली स्मोक को कम कर सकते हैं, फोग को कम नहीं किया जा सकता। नेचुरल ट्रोपोलॉजिकल कंडीशन इनको फेवर करती हैं। ये गर्मियों में काफी मॉइस्चर हिमालयन डोमेन के अंदर ट्रैप होती है। जब सर्दियां होती हैं यही मॉइस्चर जो ना वो कंडेंस हो जाती है टू दी फॉग एंड टेम्परेचर इन्वर्जन brings the pollutants and this comes for smoke. ये देखिए बैरियर, माउंटेन बैरियर जो ना वो इसको ट्रैप करता है। इसलिए आप जो कि मेन जो पोल्यूशन की वजह जो ये बांग्लादेश से लेके अफगानिस्तान तक जो हिमालयन रेंज के साथ साथ जो बैरियर है वो ह्यूमिडिटी पोल्यूटेंट्स को रिएक्ट करवाता है। We are only 9% global greenhouse gases contributors, but we are affected in 18th number in the world. एयर क्वालिटी इंडेक्स हमारा सर्दियों में बढ़ जाता है क्योंकि पोल्यूशन 3 तरफ से आती है। टेम्परेचर इन्वर्जन की वजह से सारा साल जो हम एयर पोल्यूशन क्रिएट करते हैं वो लोअर टेम्परेचर की तरफ मूव करती है। लोअर टेम्परेचर किधर है? ऊपर की तरफ। ऊपर सारा पूरा साल मीठी पड़ती है और वो जब सर्दियों में टेम्परेचर इन्वर्जन की वजह से ऊपर से भी नीचे आती है, नीचे से भी हम बनाते हैं और हॉरिजॉन्टल मूवमेंट, ट्रांसबॉडी मूवमेंट के जरिए भी आती है। तो जो अगर काम कंडीशन हो जाती हैं इस एरिया में, हवा नहीं चलती और ऐसे ही है जैसे आपका किचन का एग्जॉस्ट फैन बंद हो गया और वो सारे पोल्यूटेंट अंदर जमा हो जाते हैं, तो इन सिटीज में भी पोल्यूटेंट कंटेमिनेट अकोमुलेट हो जाते हैं। इसलिए इनका हल, कंप्लीट हल सिर्फ फोग नहीं खत्म की जा सकती, स्मोक कम की जा सकती है कि हम पोल्यूशन कंट्रोल मेजर्स या अल्टरनेट फ्यूल ले लें। क्योंकि 85% पोल्यूशन शहरों में सिर्फ फॉसल फ्यूल की वजह से है। इसलिए रिफॉर्म्स, अल्टरनेटिव्स शहरों के अंदर चाहिए। ये विंड और टेम्परेचर की वजह से, जब विंड चलती है तो हमारी स्मोक डेंसिटी कम हो जाती है क्योंकि वो बिग सिटीज के अंदर जो अकोमोडेशन है वो फ्लोन अवे हो जाती है। दूसरी जो ना ये वाले जो टेम्परेचर है वो उसकी वजह से कंडेंस होती है, वो ज्यादा हो जाती है, डायरेक्टली प्रोपोर्शनल है। मेरे ख्याल ये ना प्रेजेंटेशन जो थोड़ा हैवी है, इसके अंदर मूवीज हैं इसलिए वो आगे नहीं चलती। ये कंपैरिजन है, इसको रहने दें, ये जरा टाइम मांगता है। ये मुख्तलिफ ये लाइट ये नहीं है, किधर है? अच्छा, टोटल एनर्जी में 95% जो ना फ्यूल फॉसल फ्यूल पे इस्तेमाल होता है। फॉसल फ्यूल जो ना 85% जो ना वो 82% ग्लोबल एनर्जी सप्लाई हमारी वो पूरी कर रही है। तो अबंडेंट क्वांटिटी में फॉसल फ्यूल इस्तेमाल हो रहा है, बहुत सारी ग्लोबल वार्मिंग गैसेज इसमें ऐड हो रही हैं और ये 6 किलोमीटर पे जाके ट्रैप हो जाती हैं और ये ग्लोबल वार्मिंग फिनोमेना का मेन कंट्रीब्यूटर फॉसल फ्यूल है। ये नॉन रिन्यूएबल इसलिए है कि ये बनता तो है लेकिन मिलियंस ईयर चाहिए, इसलिए हम इसको कंसिडर करते हैं कि ये नॉन रिन्यूएबल रिसोर्सेज में शामिल है और रिप्लेनिश नहीं हो सकता। इसको यूज करते हैं तो हमारी लाइफ में रिप्लेनिश नहीं होगा। ये किसी भी कंट्री में जाएं उसमें फॉसल फ्यूल टॉप पे होगा जो इसका कंजम्पशन है। इसकी वजह से हर इंसान का, हर इंडिविजुअल का फुटप्रिंट बढ़ रहा है। फर्ज करें फुटप्रिंट वो होता है कि जो एक इंसान मुख्तलिफ एक्टिविटीज में कार्बन डाइऑक्साइड करता है। अगर आप फूड जाया करते हैं तो फूड को आप तक प्रोसेस करने तक मतलब एक ओवन चलेगा, उसके बाद पेस्टिसाइड इंसेक्टिसाइड की फैक्ट्रियां, टूवल चलेगा, ट्रांसपोर्ट चलेगी और बहुत सारी जो ना चीजें चलेंगी और ये सारे के सारे दौरान आपके फॉसल फ्यूल ही इस्तेमाल होंगे। हर मशीन फॉसल फ्यूल से चलती है, ट्रक भी उससे चलता है, ओवन भी उससे चलता है, ये सारी की सारी जितनी भी नॉन रिन्यूएबल एनर्जी से चलती हैं और ये तकरीबन एक इंसान का कार्बन फुटप्रिंट है। हमारे यहाँ तकरीबन 4 टन पर ईयर है पर पर्सन और अमेरिका में 16 है। तो इसलिए हर ये पोल्यूशन जो स्मोग है वो इंडस्ट्री की वजह से नहीं है, ये हम लोगों की वजह से है क्योंकि हम लोगों के पास कारें हैं, हम लोग फॉसल फ्यूल के कंज्यूमर हैं और कोई भी कंज्यूमर अपने एनवायरमेंटल सिस्टम को कोई भी पे नहीं करता, सारे ही यूजर हैं बट नन ऑल आर नॉन पेयर्स। ये लंदन स्मोक भी फॉसल फ्यूल की वजह से आई थी। एक्सट्रीम सर्दी में लोगों ने फॉसल फ्यूल कोल की शक्ल में बर्न किए और उसके बारे में जब एक प्रॉब्लम आती है उसका एक सोल्यूशन आता है। क्लीन एयर एक्ट इसी कंसिक्वेंसेस में आया था। तो स्मोक ने, केमिकल स्मोक थी, वो सब ने इन्वॉल्व कर लिया था वो पूरा लंदन वो शहर सिटी। बेशुमार लोग जो ना वो बीमार हुए, यानी कि इनकी डेथ हुई। ये सिर्फ ग्लोबल वार्मिंग की सिंपल लफ्ज है, इसके अंदर चूंकि हमारे फ्लोरा फाना जो रीजनल एंड सीजनल क्रॉप्स है सारी डिस्टर्ब हो जाती हैं। आप अंदाजा करें कि अगर कोई हमारी क्रॉप है वो खास सीजन में फ्लावरिंग होती है, अगर वो कंडीशन ना आए तो उसमें फ्लावरिंग नहीं होती और वो एनवायरमेंटली बांझ हो जाती है और वो उसका जो इसको कहते हैं एनवायरमेंटली इनफर्टाइल हो जाती है। इसलिए इसकी ग्लोबल वार्मिंग की वजह से या तो हमारी इंडिजिनस फसलें एलियन हो गई हैं, इनएक्टिव हो गई हैं। अगर आप कोई नॉन इंडिजिनस पौधा लेके आए उसको फ्लावरिंग नहीं होगी। अगर आप उसको इंडिजिनस एनवायरमेंट में ले जाएं तो फ्लावरिंग, इसीलिए टनल फार्मिंग इसी कंसूल के साथ बनाई गई है कि पौधे को रिक्वायर्ड एनवायरमेंट दें तो बेशक किसी भी मौसम में आप उनसे यील्ड ले सकते हैं। ये पौधे सोच के नहीं, पौधे रिस्पॉन्स करते हैं एनवायरमेंट को। ये नहीं है कि बीज जिस दिन लगा लिया उगाएंगे, ये एनवायरमेंट की मानते हैं और एनवायरमेंट कंडीशन को ये कंपैटिबल है, कंपैटिबिलिटी होनी चाहिए। बहुत सारी जमीन ग्लोबल वार्मिंग की वजह से हमारी जो फर्टाइल लैंड है, सॉइल है, क्ले में बदलती जा रही है, डेड हो रही है, उसके अंदर बैक्टीरिया खत्म हो रहे हैं, पौधे नहीं हो सकते उसके अंदर। इससे के अलावा हमें एनवायरमेंट नॉन सस्टेनेबल मिलेगा, या फ्लड मिलेंगे या ड्रॉट मिलेंगे। जब ये बहुत तेजी से हवा चलती है, क्योंकि टेम्परेचर एक एनर्जी है, तो ये हॉरिजॉन्टल चलती है, तो कभी 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 ये जो हवा है ऊपर की ह्यूमिडिटी हवा ऊपर की सतह में चली जाती है और रैपिड कंडेंसेशन होती है, जिसकी वजह से गर्मियों में ओले पड़ना शुरू हो जाते हैं। कभी कभी ओले भी नहीं पड़ते, लेकिन बहुत ज्यादा गर्मियों में ठंड आ जाती है। इसकी वजह से यह है कि हॉरिजॉन्टल मूवमेंट लोअर सरफेस पे होती है, तो ऊपर की ठंडी हवा रोल बैक करके जैसे छत ऐसे नीचे आ जाए। तो ये हमने छत खत्म करनी है जो ग्लोबल वार्मिंग गैसेस ने बनाई हुई है, 30% जो हमारी एनर्जी को ट्रैप करती है। तो ये इसका क्या हाल है? दो तरीके हैं, एक हम प्रिवेंट करें, अल्टरनेटिव एनर्जी पे जाएं, या हम इसको रेमेडी मेजर इख्तियार करें। इसके लिए पौधे लगाएं जो कि कार्बन डाइऑक्साइड ग्लोबल वार्मिंग गैस को कंज्यूम करते हैं। ग्लोबल वार्मिंग गैस से सारे के सारे प्रॉब्लम एसोसिएटेड है, हमारे बेशुमार जो फ्लोरा के और फाना के और हमारी रोजमर्रा लाइफ के। देखो कि ये मेरे हाथों की तस्वीर ही उतरी हुई है। तो ये पहले तो स्मोक प्लस फॉग था, अब बहुत सारी पोल्यूशन की किस्में आ गई हैं, इसलिए फॉग की किस्में हैं। ये सारा साल ऊपर को कमेटी पड़ती रहती है पोल्यूशन की, और हमारी सर्दियों में ये सारी नीचे आ जाती है, इसलिए हमारे 100% मेजर्स के बावजूद भी स्मोक फिर भी रहती है। ये ऊपर जाके केमिकल आपस में रिएक्ट करते हैं, उसमें सनलाइट जो ना उसको जो अल्ट्रावायलेट रेज हैं और IR इसको एनर्जी देती है रिएक्टर के, और वो सेकेंडरी पोल्यूटेंट बनते हैं। सेकेंडरी पोल्यूटेंट जो हमने इधर से भेजे होते हैं वो वापस किसी और शक्ल में आते हैं। ये इसके लिए जो रेमेडी मेजर है कि हम लोग ऐसे दरख्त लगाएं वो फास्ट ग्रोइंग हो। फास्ट ग्रोइंग का मतलब होता है कि वो तेजी के साथ कार्बन सिक्वेस्ट्रिंग कर रहे हैं। कार्बन सिक्वेस्ट्रिंग का मतलब है कि वो कार्बन लेके लकड़ी बनाते हैं। सफेदे का दरख्त सब 1 टाइम्स ज्यादा कार्बन सिक्वेस्ट्रिंग रेट रखता है। वाटर जो ज्यादा लेता है, लेकिन वो कार्बन सिक्वेस्ट्रिंग, देखिए हर चीज की कोई ना कोई खामी भी होती है, खराबी भी होती है। एवरी प्रॉब्लम हैज ए सॉल्यूशन, एवरी सॉल्यूशन हैज अ प्रॉब्लम। वासा ने जब सिस्टम शुरू किया तो सारा का सारा जो हमारा का जो एक्सक्रीटा था वो सरफेस वाटर बॉडी में चला गया और सारी की सारी तबाही हो गई। सारे अब कहीं भी मछली नजर आती है। जब स्टबल बर्निंग पहले में प्रमोट करते थे कि आप एक फसल का गुणवा दूसरे में ना जाए, प्रॉब्लम क्रिएट हुई, हमने बंद करवाया कि ये स्मोक पैदा होती है। तो एक सोल्यूशन दिया था तो उसकी प्रॉब्लम हो गई। तकरीबन एक दरख्त जो ना 24 किलो डाइऑक्साइड यानी ग्लोबल वार्मिंग गैस को जज़ब करता है। तो इसलिए तकरीबन हर नहीं, जिसकी बहुत लो खजूर का दरख्त, इसलिए सुप्रीम कोर्ट हाई कोर्ट ने इसको बंद कर दिया कि मोटरवे के गिर्द जो स्लो ग्रोइंग दरख्त हैं वो ना लगाएं। वो तो आप बड़ी मुश्किल से जो ना वो सालों बाद इतने होते हैं। तो इसलिए जो फास्ट ग्रोइंग का मतलब होता है कि फास्ट कार्बन सिक्वेस्ट्रिंग उसके अंदर मौजूद है। ये एक मैंने मिसाल दी है कि जब ये कंडीशन नहीं आएंगी, कंपैटिबल कंडीशन नहीं आएंगी, ये आपके किसी भी फसल में फ्लोरिजन नहीं पैदा होगा, ना ही फ्लावरिंग होगी, कंसिक्वेंटली कोई भी फ्रूट नहीं हो सकेगा। तो ये आप लोगों ने पढ़ लिख के हमारे डिपार्टमेंट में ही जाना है। उसके अंदर हर किस्म की क्वालिफिकेशन है, केमिकल हमारी लैब्स है। अब तो ये देखे जो पीले रंग के हैं, ये हमारा नया डिपार्टमेंट इस साल इसके अंदर शामिल हो जाएगा। ये सिर्फ और सिर्फ पढ़ने से चीज़ें ख़त्म नहीं होती, इसके लिए इन्फोर्समेंट की हायरार्की होनी चाहिए, लॉ होना चाहिए। तो इसलिए कंट्रोल की बड़ी सारी किस्में होती हैं। एडमिनिस्ट्रेटिव कंट्रोल है, टेक्निकल कंट्रोल है, रिसर्च एंड इन्वेस्टिगेशन है, जैसे कि आप लोग करते हैं, और रिकमेंडेशन होती है। ये हमारा ट्रिब्यूनल है जिसके अंदर मुख्तलिफ केसेस आ सकते हैं जो कि पोल्यूशन पैदा करते हैं। दिस इज द डेफिनेशन ऑफ एनवायरनमेंट। यू कैन सी देयर इज नथिंग आउटसाइड आवर एनवायरनमेंट, एवरीथिंग इज एनवायरनमेंट, एंड अ थिंग एट इट्स इम्प्रॉपर प्लेस इज कॉल्ड वेस्ट। If all things are its right place, there will be no waste in the concept of universe. वेस्ट ऑफ वन इज रॉ मटेरियल ऑफ अदर। एडवर्स एनवायरमेंटल इफेक्ट की अगर डेफिनेशन पढ़ लें तो एडवर्स एनवायरमेंटल इफेक्ट हेल्थ तक ही नहीं है, प्रॉपर्टीज है, बिल्डिंग्स भी हैं और वापडा की तनसीबात में भी है। मैंने 3 भट्ठे डिमोलिश करवाए। वापडा की जो मेन लाइन थी उसकी जो इंसुलेटिंग प्लेट थी, पोल्यूशन की वजह से वो कंडक्टर हो जाती थी और अर्थ होने की वजह से वो तो भट्ठों की कार्बन उसके ऊपर डिपॉजिट होके उसको इंसुलेटर को वो कर देती, कंडक्टर कर देती थी। इसलिए हमारी बिलोंगिंग्स, हमारी प्रॉपर्टीज, हमारी हेल्थ, हमारे एनवायरनमेंट, किसी को भी डैमेज करने वाली कोई भी चीज एडवर्स एनवायरमेंटल इफेक्ट में आएगी। हमारे स्टैंडर्ड हैं बहुत सारे, उसकी मेन कैटेगरीज हैं स्टैक एमिशंस। स्टैक एमिशन होता है कि जो चिमनी से निकलता है, जो रिक्शे के सलेंसर से निकलता है, ये प्यूनिटिव होते हैं, ये सब पे सजा होती है। जो एम्बियंट हैं, एम्बियंट प्लानिंग के लिए होते हैं। एम्बियंट में क्यूमुलेटिव इफेक्ट है, आपकी गाड़ी का भी धुआं है, आपके घर के चूल्हे का भी धुआं है, जो भी चीजें आप कंट्रीब्यूटर हैं वो सारे, इसलिए वो प्लानिंग के लिए। मसलन महमूद बूटी में एयर पोल्यूशन बहुत ज्यादा है, वहां हम कहते हैं कि वहां पे बैन है एयर पोल्यूशन की फैक्ट्री, वहां पर ये लग सकती है, ये वाटर पोल्यूशन वाली लग सकती है, वो मैनेज करें, क्योंकि क्यूमुलेटिव इफेक्ट कंप्लायंस और लॉ के बावजूद भी हो जाता है। उसके बाद एयर क्वालिटी इंडेक्स है। एयर क्वालिटी इंडेक्स कोई नया स्टैंडर्ड नहीं है, ये हम जो टेक्निकल लोग जो ना वो करते हैं ना, सॉक्स नॉक्स उसकी कंसंट्रेशन, उसको उन्होंने एक वेटेज दे के एक इंडेक्स बनाया हुआ है ताकि आम लोगों को पता चल जाए कि 100 से ऊपर जो ना ज्यादा हैजर्डस होता है, 500 वाला एक्यूट हो जाता है फलां। तो ये इसलिए ये हमारा एयर क्वालिटी इंडेक्स बने हुए हैं। क्वालिटेटिव स्टैंडर्ड भी हैं कि ये करो ना करो, हॉस्पिटल वेस्ट मैनेजमेंट है तो वो इंस्ट्रक्टिव होते हैं। बदकिस्मती से हमारे ग्रीन हाउस गैसेज के कोई स्टैंडर्ड नहीं है। हम कहते हैं कि आप दरख्त लगाएं, कहीं नहीं लिखा हुआ कि कितने लगाएं। कई दफा कोर्ट ने भी इतराज किया कि आप अपनी बात से पीछे लॉ की बैकिंग हुई कि कोर्ट लॉ की बात करती है, वो ये नहीं करती कि इसने अच्छी बात की है। पाकिस्तान में 8 एनवायरमेंटल लॉज हैं और 7 EPA हैं। 4 सूबों में हैं, 2 रीजन्स में हैं, कश्मीर और गिलगित बल्तिस्तान, तो सेंटर में है। सेंटर वालों के पास 2 लॉ हैं, क्लाइमेट चेंज एक्ट और पाकिस्तान एनवायरमेंट प्रोटेक्शन एक्ट, बाकियों के सबके पास अपने अपने। और एशिया में सबसे ज्यादा अच्छा निज़ाम एनवायरमेंट की स्कोपिंग का पाकिस्तान में है। ये हमारे इस 2023 में स्मोक रूल्स बने हैं जो कि मौके पे जाके 10 मिलियन तक जुर्माना कर सकते हैं, सील कर सकते हैं, क्योंकि ये प्रॉब्लम कंट्रोल नहीं हो रही थी। हमने कभी दफा 144 लगवाई, कभी हमने स्मोक को क्लेमिटी डिक्लेयर कराया, कभी हम PPC लगाते थे, तो लेकिन अब हमने अपना ला ये सारे मैंने ही बनाए हैं। ये ज्यादातर टेक्नोलॉजिकली क्योंकि मैं है तो बेस मैंने इनिशिएट किया है। अब हमारी यूनिफॉर्म बन रही है, यूनिफॉर्म भी डिजाइन मैंने किया, प्रूफ जाहिर है कि हमारे से ऊपर वालों ने करनी होती हैं, वो अब तकरीबन नोटिफिकेशन के स्टेज में है। तो हमारी एनवायरमेंटल पुलिस अनकरीब आपको सड़कों में नजर आएगी जो कि आपकी गाड़ियों को रोकेगी। ये हमारे मैंने 200 से पीछे 200 से पीछे शो नहीं किए, वो तकरीबन कम उनका इम्पैक्ट होता है, इनका इम्पैक्ट है। ये हमारे इंडस्ट्रियल डिस्ट्रिक्ट्स हैं। हमारी क्लीन एयर पॉलिसी में भी फॉसल फ्यूल को डिस्कस किया गया है। उसमें हमें सोलर और विंड एनर्जी, जो भी अभी सर ने पहले ने बताया है ना, डीजल का भी गाड़ी का वो सारा सिस्टम मुझे पता है। फूड हमारा भी क्लैश रहता है क्योंकि हम लोग NOC देते हैं इन फैक्ट्रियों को जिधर बायोडीजल बनता है। तो ये मुख्तलिफ किस्म के देखें, एक तो प्रॉब्लम हो जाए कि ना होए, प्रीएम्प्टिव मेजर्स होते हैं, ना हो, अगर आप डिस्कस करें जो चीज करती है, लेकिन जो हो जाता है तो उसके लिए रिमीडियल मेजर्स हैं। ये हमारे स्क्रबर्स हैं, ड्राई स्क्रबर, वेट स्क्रबर, केमिकल स्क्रबर, फिल्टर बैग्स, बहुत सारी किस्म के जो ना पोल्यूशन कंट्रोल या एमिशन कंट्रोल मेजर्स होते हैं, और ये बहुत सारी जगह पे लगे हुए हैं। हम आप लोगों को इसलिए नजर नहीं आते क्योंकि आप इंडस्ट्रियल एरिया में जरा कम ही जाते हैं। आपके ही डिपार्टमेंट से AR सलीमी साहब हमारे ट्रिब्यूनल के टेक्निकल मेंबर रहे हैं 3 साल तक। जानते हैं कोई AR सलीमी साहब को? आप जो पहले थे सर जानते हैं केमिकल इंजीनियरिंग, हाँ जी HOD रहे हैं। तो वो हाँ जी वो उनकी मेरे बड़े बेस्ट फ्रेंड थे, मैंने उनको वो यहाँ पर देखें ये वहाँ पे उन्होंने बहुत अच्छी एजुकेशन की है, क्योंकि हमारे जो होते हैं वहाँ पे जज होते हैं वो टेक्निकली साउंड नहीं होते हैं। इन्होंने टेक्निकली साउंड पे पहला एक आपके इदारे से ऐसा टेक्निकल मेंबर आया जो कि बहुत ज्यादा अच्छा साउंड उनकी ग्रिप थी, मैंने उनको बड़े विजिट कराए हैं। ये हमने पोल्यूशन कंट्रोल मेजर्स के लिए 1 करोड़ तक एक फैक्ट्री को है, 2 अरब की लोनिंग स्कीम है पंजाब स्मॉल इंडस्ट्रीज के जरिए ये प्लान करते हैं, हम अप्रूव करते हैं और ये सोलर पैनल लगाएं, पोल्यूशन कंट्रोल मेजर लगाएं, ये मुख्तलिफ किस्म की ये हो जाते हैं, मिलते हैं। ये हमने 180 ईयर्स ओल्ड ब्रिक किलन टेक्नोलॉजी, जिसको बुल ट्रेंच की टेक्नोलॉजी की, हमने इसको कन्वर्ट करवा दिया, तकरीबन 80% कन्वर्जन हो गई है। उसमें कोई भी नई चीज नहीं आई, उसमें यह है कि उनकी कंबस्चन बेहतर की है, रिटेंशन टाइम बेहतर किया है। कंबस्चन हमने 100% करवाई है, जिसकी वजह से तकरीबन ये हमारा 30% फ्यूल बचता है और 70% उसकी हमारी पोल्यूशन कम हो जाती है। ये जिग-जैग से मराद जिग-जैग फायरिंग टेक्नोलॉजी पूरा इसका नाम है। ये है कि जिग-जैग एक तो हीट रिकवरी होती है, यूनिफॉर्म बेकिंग होती है, और ये दूसरे में लीनियर था, उसमें बहुत सारी हीट लॉस होता था, कच्चा फ्यूल बाहर निकलता, उसके अंदर हमारा कंट्रोल ही नहीं था। इसके अंदर क्योंकि ब्लोर होता है, हम उसको देख लेते हैं कि वो किस ये इसकी जिग-जैग की बेशुमार कोई 5-6 किस्में हैं, और वो उसमें से हमने नेचुरल ड्राट और फोर्स ड्राट 2 रिकमेंड किए हुए हैं। चाइना में ये वर्टिकल शाफ्ट वाले चलते हैं, हमारे यहाँ ये बहुत सारे ये देखें बहुत सारे जुर्माने एट द स्पॉट हमने स्मोक रूल्स में शामिल किए हुए हैं। उसके अंदर गाड़ियों का भी है, सबका दोनों वो जुर्माने हैं। ये पेरिस एग्रीमेंट, इसके अंदर भी हम सिग्नेटरी हैं। वी हैव टू रिड्यूस ग्रीन हाउस गैसेस। वी हैव 2 इंटरनेशनल treaties on reduction of greenhouse gases. नेशनल क्लाइमेट चेंज पॉलिसी हमने इसीलिए बनाई है कि इसको हम अचीव कर सके। उसके बाद ये भी है कि पाकिस्तान नेशनली डिटरमिन्ड कंट्रीब्यूटर्स को 2030 तक हमने उसको दिया कि 20% तक हम इसको कम करेंगे और 2030 तक 50%। ये ट्रीटमेंट टेक्नोलॉजी है हमारी ग्रीन टेक्नोलॉजीज हैं, जो कि इसके अंदर बायोडीजल भी है, बायोगैस भी है, हाइड्रोजन सेल्स भी हैं, और बेस पायरो ऑक्सीडेशन है, जिग-जैग फायरिंग टेक्नोलॉजी है, ओजोनेशन प्रोसेस है, मेम्ब्रेन बायोरिएक्टर्स हैं, कार्बन सिक्वेस्ट्रिंग है, इंसिनरेटर पायरोलाइसिस, कंपोस्टिंग और जियो थर्मल एनर्जी है। ये बहुत सारी हम इसको हम लोगों ने पढ़ लिख के आगे इसको रिकमेंड करना है, क्योंकि लोग तो टेक्नोलॉजी छोड़ने के लिए तैयार नहीं है। उसके ये स्क्रबर है, स्क्रबर का एक ही है कि पाउच के जरिए सक करते हैं, उसके बाद आप पोल्यूशन को स्क्रबर के जरिए गुजार दें या उसको शावरिंग चैम्बर के जरिए गुजार दें, ये और या हम सेंट्रीफ्यूगल सिस्टम कर दें। ये सारे स्क्रबर हैं। स्क्रबर की कोई बहुत सारी किस्में हैं। ये लगा हुआ है मुगल स्टील मिल में, सबसे बड़ा पंजाब का यही है जो इसके अंदर जो स्क्रबर लगा हुआ है। ये लाखों रुपए का लगता है एक, और वहाँ पे 2 लगे हुए हैं, और ये फैक्ट्री चल रही हो तो आप बाहर से देख नहीं सकते कि ये चल रही है, धुएं का नामो निशान नहीं होता। सॉलिड वेस्ट के लिए भी बहुत सारी टेक्निकल हमारी कंपोस्टिंग है, सैनिटरी लैंडफिल है, वेस्ट टू एनर्जी है, रिफ्यूज ड्राइव फ्यूल्स हैं, गैसिफिकेशन है, एनारोबिक डिकम्पोजिशन है, पायरोलाइसिस इसका भी हो जाता है या इसको कार्बनाइजेशन कहते हैं, इंसिनरेशन है, मटेरियल रिकवरी, MRF मुख्तलिफ उसके बाद एयर पोल्यूशन के लिए है वेट स्क्रबर है, मैकेनिकल है, फिल्टर है, केमिकल स्क्रबर, साइक्लोन है, इलेक्ट्रोस्टैटिक प्रेसिपिटेटर्स हैं, बैग फिल्टर है, ग्रेविटी सेटलिंग है, और ये इस तरह की बहुत सारी और भी टेक्नोलॉजी हैं। हम प्रोसेस कंट्रोल के जरिए भी पोल्यूशन को कंट्रोल कर सकते हैं। स्मोक के लिए हमने एक तो लीगल टूल्स बनाए हैं। हमने आर्टिफिशियल रेन इस दफा तजर्बा किया है दुबई के साथ मिलके। उसके बाद जो लास्टली है वो आयनिक कंडेंसेशन है, जिसके साइन मैंने किए हुए हैं। दुबई की कंपनी के साथ एग्रीमेंट है, वो अभी इसी साल लगा देगी अपने इंस्ट्रूमेंट, 6-7 लगेंगे, और वो अगले साल से स्मोक से पहले ऑपरेशन में आ जाएंगे। वो ये इसका कंडीशन है कि वो आयन्स लोअर एटमॉस्फेयर में भेजेंगे। 8 आयन स्मोक के उस आयन के गिर्द जमा होके कंडेंस होंगे। जब ये इलेक्ट्रिकली आयनिकली कंडेंस होंगे तो लेटेंट हीट ऑफ कंडेंसेशन खारिज होगी, जिसको हरारत मखसूसा कहते हैं, कि यानी कंडेंसेशन इंजमात की, तो वो इसको डिस्पर्स कर देगी। हमें क्लियर स्काई, क्लियर बिग सिटीज सारे मिलेंगे। ये टोटली फ्री ऑफ कॉस्ट है। ये वर्ल्ड लेवल पे सिर्फ उन्होंने, दुबई की कंपनी ने हमारे लिए अपनी फेम या उसकी क्लाइंट हासिल करने के लिए हमें लगा के दे रहे हैं। हमारा कोई पैसा नहीं लगेगा। अभी ये कस्टम क्लियरेंस की फेज में है। वो कह रहे हैं जी हमें कस्टम क्लियरेंस रिलैक्स करवा के दें, क्योंकि हम कौन सा आपसे पैसे ले रहे हैं। इसमें एक इस कमरे में 2-3 लग जाते हैं, इतना छोटा होता है। वो मीटर होता है और सिर्फ डीसी करंट हाई वोल्टेज से चलता है, और ये एक की रेंज 5 किलोमीटर रेडियस में होती है। 10 किलोमीटर एक डिवाइस कवर करेगा। ये आर्टिफिशियल रेन की इसका मेंबर था। ये सीएम साहब ने जो अभी निगरान थे, उन्होंने आर्टिफिशियल रेन करवाई है, लेकिन बदकिस्मती से क्लाउड नहीं आए। और क्लाउड जो ना वो हमारे विंटर सीजन में बाई चांस ही आते हैं। 1 महीना तक वो इंतजार करते रहे। स्मोक का दिनों में आप देखें, अल्लाह ताला ने हमें सिस्टम दिया हुआ है कि जो हम पार्टिकल्स को कई हिस्सों में तकसीम करते हैं। 2.5 माइक्रोन के पार्टिकल, इसको इनहेलेबल डस्ट या रेस्पायरेबल डस्ट कहते हैं। जब हम सांस लेते हैं तो 10 माइक्रोन के जो बड़े पार्टिकल्स हैं वो सीधे जब नाक में आते हैं तो नाक के चौड़े हिस्से में म्यूकस में स्टक कर जाते हैं। वो रैपिड टर्न नहीं कर सकते क्योंकि उनकी इनर्शिया डेवलप हो जाता है इतनी स्पीड से। बाकी जो 10 से छोटे होते हैं वो सीधे जाके तालू में टकराते हैं और फिर वो नीचे 45 की दाबी पे आते हैं। वो भी सेंट्रीफ्यूग हो जाते हैं। 2.5 माइक्रोन से जो अबव के होते हैं वो तालू में स्टक कर जाते हैं। जो फेफड़ों तक जाते हैं वो 2.5 माइक्रोन से कम होते हैं। इसलिए हमारे एम्बिएंट एयर क्वालिटी के स्टैंडर्ड इसी 2.5 पे बने हुए हैं, 10 पे नहीं बने हुए। ये हमारा लोनिंग सिस्टम है और ये हम ड्रोन के जरिए पोल्यूटर्स को आइडेंटिफाई करते हैं। महकमा जंगलात से हमने ड्रोन लिया हुआ है तो वो हमें लोकेशन भी दे देता है साथ ही। ये आप देखें मीनार पाकिस्तान के बादशाही मस्जिद, स्मोक और स्मोक के बगैर। और ये भला कौन सी जगह है? मॉडल टाउन है। ये स्मोक और नेचुरल तस्वीरें हैं। ये हमारा ओल्ड टेक्नोलॉजी ब्रिक किलन है और हमारे लेफ्ट साइड पे नई टेक्नोलॉजी। ये धुआं नहीं है, ये जो ईंटों की है वो मॉइस्चर है जो उससे निकलती है। ये कंप्लीट कंबस्टन की एक मिसाल है। ये सिलेक्टिव नहीं तस्वीरें नहीं, और बदकिस्मती से हमें नॉन टेक्निकल लोगों से पाला पड़ता है। अगर ये स्मोक वाइट है, कई लोग गीली ईंटें जान के चुनते हैं, उनकी क्वालिटी होती है। कई लोग खुश करके चुनते हैं। जो गीली वाले होते हैं उसमें बहुत सारी ये फोग निकलती। अगर ये सूरज है, हाँ, सूरज अगर ऑपोजिट हो तो ये वाइट एमिशन भी हमें काली नजर आती है, जैसे बादल काले नजर आते हैं। तो इसलिए वो कहते हैं जी आप मुझे बेवकूफ बना रहे हो, काला धुआं है, आप इसको जो आप वाइट कैसे कह रहे हो। वो हमारे सेक्रेटरी साहब को रिपोर्ट कर देते हैं कि ये बंदा आपका झूठ बोलता है। नहीं, आगे पीछे आ रही है? नहीं नहीं आगे चल रही है। करें आगे, आप करें, मैं आप जब इधर से करें, आगे करें आगे, जल्दी जल्दी करें, टाइम थोड़ा हो गया है। ये देखें, आप इसको चला के देखें, ये मेरे अपने कैमरे से नेचुरल तस्वीरें हैं। ये कैसे चल रहा है? फॉसल फ्यूल से चल रहा है, इसके अंदर कोला है। तो ये पुरानी टेक्नोलॉजी हमने रिप्लेस की है। ये राइट साइड पे जो है आपकी नई टेक्नोलॉजी है। नेक्स्ट नेक्स्ट। अब पहले हम लोहे को पिघलाते थे फॉसल फ्यूल से, बहुत ज्यादा पोल्यूशन पैदा होती थी, लेकिन हम अब आए हैं इंडक्शन फर्नेस पे, जिसमें फ्यूल जो है ना बिजली होती है। बिजली भी जाहिर है फॉसल फ्यूल से ही बनती है, पीछे जो भी है, ये भी लाइटें भी फॉसल फ्यूल से ही चल रही हैं। तो इसलिए जो भी टेक्नोलॉजी हम इलेक्ट्रिक बाइक लेके आएंगे तो उसको चलाने के लिए पीछे फॉसल फ्यूल ही इस्तेमाल होता है। अब एक किसी को चलाएं जरा, चलाएं। हमारे राम जो बाहर से लाते हैं, इंतहाई इसके अंदर रेजिडुअल मटेरियल होते हैं, कोटिंग मटेरियल होते हैं, इम्प्योरिटीज होती हैं, रबर रिएक्शन वो बर्न होती है। अदरवाइज इसके अंदर फ्यूल इलेक्ट्रिसिटी है। दूसरी ये देखिए, ये तो मटेरियल पे डिपेंड करता है। ये इंडक्शन फर्नेस है, इसमें फ्यूल कोई नहीं है, बिजली है। नेक्स्ट, अब ये चलाएं। ये इसके अंदर कुछ टायर इस्तेमाल किए गए हैं, और वो टायर के अंदर भी आपको पता बहुत सारा फॉसल फ्यूल यानी कि ऑयल इस्तेमाल होता है, और टायर से डीजल निकलता है, पेट्रोल भी निकलता है। ये भी उसी की आगे ये वाला चलाइए, ये वाली, ये जो लेफ्ट है। ये पुरानी टेक्नोलॉजी में हेल्थ एंड सेफ्टी है जी। जब भी सुराख में फ्यूल डालेगा, इट विल हार्म दी वर्कर। देखिए आप कैसे इसको चलाएं जरा, वो देखिए इसकी मिसाल होती है कि जो व्हाइट धुआं होता है कुछ देर के बाद खत्म हो जाए ना, तो वो धुआं नहीं होता, वो स्टीम होती है। वो स्टीम खत्म होती है, नजर आ रही है। नेक्स्ट पे दूसरी, नेक्स्ट जल्दी। ये देखिए, हर दफा एक तो हीट लॉस हो रहा है, और इसके अंदर चिमनी के अलावा इधर से भी धुआं निकलता है, और वो बंदे को भी इफेक्ट करती है। नेक्स्ट, पुरानी टेक्नोलॉजी। और ये है अभी जिसने धुआं दिया है, ये हमारा रॉ मटेरियल दुबई वगैरह से आता है, और इसके अंदर जितनी भी कोटिंग मटेरियल, डिपोजिशन है, इम्प्योरिटीज हैं, वो जलती हैं तो वो धुआं देती हैं। नेक्स्ट, ये हमारी मॉनिटरिंग है। नेक्स्ट, ये हमने वो अभी हमारे पास कुछ टेक्नोलॉजी नहीं है, मैनुअली ये चीजें हमने ट्रांसप्लांटेशन की है। नहर के किनारे पे एक प्रोजेक्ट था। थैंक यू।
Thank you, Dr. Yunus, for your presentation. Is there any question from the audience?
अस्सलाम वालेकुम सर, थैंक यू वेरी मच। बड़ी इन्फॉर्मेटिव और बड़ी एग्जॉस्टिव किस्म की प्रेजेंटेशन थी। आई एम डॉक्टर फारूक, और मेरी पीएचडी भी वेस्ट टू एनर्जी में ही है। प्रैक्टिकली बहुत सारी चीज़ें आपने दिखाई जो पंजाब गवर्नमेंट और हमारे एक्ट के अकॉर्डिंगली हम लोग कर रहे हैं, लेकिन उसी के अगेंस्ट हम पैरेलल में अगर देखें, प्रैक्टिकली हर साल हमें वो स्मोक के इश्यूज आते हैं, और हम देखें कि वेस्ट है, बेसिकली वो कहते हैं वेस्ट तो गोल्ड है एक्चुअली, ठीक है। ये ना सिर्फ आपको एनर्जी दे रहा है बल्कि इन्वायरमेंट को भी वो सस्टेन कर रहा है, और फिर उसके जो फर्दर आउटकम है वो फर्टिलाइज़र भी हैं, और ये वो सारी इस तरह की चीज़ें। तो आप सर क्या समझते हैं कि हमारे जो बेसिकली पॉलिसी मेकर साइड पे आप हैं, तो ये कब चीज़ें जो है ना वो थोड़ी थोड़ी प्रैक्टिकली जो है ना वो उस तरफ आएंगी? मतलब होता क्या है यहाँ पे, जो मेरी अंडरस्टैंडिंग है कि कोई ना कोई छोटे मोटे पायलट प्रोजेक्ट होते रहते हैं, ठीक है, और वो सम टाइम अब जैसे एसिड रेन जो है वो आर्टिफिशियल रेन वो की गई, या इस तरह की और चीज़ें। तो प्रैक्टिकली कब अगर हमारे पास एक बहुत बड़ा रिसोर्स है जो पीएचडीज की फॉर्म में है यूनिवर्सिटीज़ के अंदर, जिनको सिर्फ वो जो एचईसी की ग्रांट्स हैं या पीएचईसी की ग्रांट्स हैं, वो उनके बड़े टिपिकल किस्म के ऑब्जेक्टिव होते हैं, वो रिसर्च पेपर से पूरे हो जाते हैं, हम पेपर भी पब्लिश कर लेते हैं।
वेस्ट टू एनर्जी प्रोजेक्ट था लाहौर में, सुंदर के पास। लोगों ने नहीं बनने दिया, लोगों ने, उनके कंसल्टेंट्स ने कहा जी ये तो बहुत सारी पोल्यूशन पैदा करेगा, इसके अंदर कोई अनलिमिटेड स्टैंडर्ड किस्म की पीवीसी बर्न होगा और हम खराब हो जाए। प्रोटेस्ट हुआ। दूसरा आरडीएफ था, रिफ्यूज ड्राइव प्लांट। इधर कोई 10 एकड़ में डीजी खां सीमेंट वाले ले जाते थे। उनकी इंडिया के साथ एक्सपोर्ट जब बंद हो गई ना, तो वो ऐसे करते थे, सीमेंट ले जाते थे और वापसी पे ये ले जाते थे। वो उन्होंने बंद कर दिया कि अब हम इधर से लेके आएंगे फिर लेके जाएंगे तो हमें महंगा पड़ता है, वो भी खत्म हो गया। इन्होंने सैनिटरी लैंडफिल बनाई, उसको इस्तेमाल नहीं किया, दिखाने के लिए रखा कि जब को फॉरनर आएंगे हम उसको दिखाएंगे कि ये हमारी है। इर्द गिर्द फेंकते रहे और इर्द गिर्द फेंकने के बाद इन्होंने वहां पे कार्बन क्रेडिट भी लिया कि हम देखे हम साइंटिफिक डिस्पोजल कर रहे हैं। जब ये बहुत सारे डिप्रेशन भर रहे थे, इन्होंने उसको अपना किए पे पानी फेरने के लिए किए पे मिट्टी फेरी और उसको ऊपर से बंद कर दिया चिकनी मिट्टी डाल के। जब कर देते थे उसके अंदर बायोगैस बनी और वो सैंडी बेड है, वो सैंडी बेड जो ना वो कहीं से किसी ने नलका लगाया तो पर्कुलेट हुई, वहां पे वो निकली और वो आग लग गई। अब उन्होंने उसके अंदर पहले तंदूर लगाया मजदूरों के लिए। अब वहां पर अनिलिंग फर्नेस की 2 फैक्ट्रियां चल रही हैं, 2 फैक्ट्रियां चल रही हैं। वो हर वक्त नीचे से बायोगैस सीपेज हो के वहां से नेचुरल निकलती है। वो जब उन्होंने बंद करना होता है वो बोरी दबा के ना तो उस सुराख को बंद कर देते हैं।
नहीं, मेरा क्वेश्चन ये है, अब आपने वो सलीमी साहब का जिक्र किया, मैंने सलीमी साहब के साथ काम किया हुआ है 2008 में। वो पंजाब गवर्नमेंट के साथ वो जो छोटे छोटे बायोगैस प्लांट्स थे ना, ये लाहौर के
बायोगैस के प्लांट सारे मैंने उनको विजिट कराए हुए हैं।
हाँ जी, तो ये चीजें गवर्नमेंट नहीं आती है, ये चीजें उस हिसाब से उस तरफ चली जाती है।
बायोगैस प्लांट के लिए थोड़ी सी डेडिकेशन की जरूरत है। सर्दियों में फिर चलता नहीं है, ये टेम्परेचर कम हो जाता है या इसकी जो डोजिंग होती है। मेरा बेटा भी एनवायरमेंटलिस्ट है, वो PSO2 सेक्रेटरी और DG भी है और वो पंजाब यूनिवर्सिटी का पढ़ा हुआ है। उसने बायोगैस प्लांट वहां पर पंजाब यूनिवर्सिटी में लगाया। उसने जब तक तो वो वहां पे रहा, उसने ट्रालियां बार बार के ला के तो उसकी किचन भी चलता रहा उससे। जब वो चला गया किसी ने मेहनत नहीं की। हमारे यहाँ जो ना असल में मेहनत नहीं करते।
इसी बात से मुझे याद आया, हमारे कालाशाह काकू में बायोगैस प्लांट लगाया गया।
बिल्कुल, उसमें वहां पर बायोगैस प्लांट से एक राइस मिल चलती है, वो ड्राई उसको बर्न करके तो सन ड्राई की बजाय उससे ड्राई करते हैं। वो चल रहा है काफी।
वो गवर्नमेंट शहबाज शरीफ का आपका विजिट था जब सराड़ की इनागोरेशन होनी थी 2012 में, तो उन्होंने कहा ये क्या स्मेल आ रही है, ये शहबाज शरीफ साहब आ रहे हैं। वो बायोगैस प्लांट जो है ना, मेरी मास्टर्स की डिग्री है उसी प्लांट पे थी, जो उन्होंने बिल्कुल मलियामेट कर दिया। क्वेश्चन ये था सर, जैसे महमूद बूटी में भी यहाँ पे ना बड़ा वो मतलब वो डिस्पोजेबल वेस्ट वगैरह सारा कुछ, तो इतना हमारे पास वेस्ट है, लेकिन प्रैक्टिकली हम जो है ना वो सोल्यूशन भी आपने सारे मेथड बताए।
मैं आपको सर बताता हूँ, टेक्नोक्रेट की ना इतनी ज्यादा नहीं मानी जाती। मैं आपको एक मिसाल देता हूँ। सरगोदे में एक डिस्टिलरी है, उसमें सिर्फ एक ड्रेन में एक ही डिस्टिलरी का पानी आता है। वो उसकी जो हाइड्रोजन सल्फाइड बनी कम के नीचे बनी, एक वो जो भैंस का जो बच्चा था ना, वहां पर उसने जब पाँव से सुराख किया तो वो वहां पे उसकी डेथ हो गई। उसका मालिक आया लेने, उसको अंदर गया, वो भी मर गया उधर। उसके बाद उसका बेटा, उसका दूसरा, 5 बंदे मर गए। जब 5 बंदे मरे, टेक्निकल कमेटी बनाई गई। टेक्निकल कमेटी के ऊपर पॉलिटिकली इन्फ्लुएंस हुआ कि हम ये जो डिजीज जो डेथ हुई है जिनकी पर्सन की, वी विल पे देम, उनको पे कर देंगे, लेकिन आप इनको टेक्निकली इनोसेंट करार दे दें। वो यकीन करें, अब मैं नाम नहीं लेना चाहता, ये पंजाब इस UD के 2 प्रोफेसर भी उसमें शामिल है। उन्होंने कहा है कि डिस्टिलरी से कोई तल्लक नहीं है हाइड्रोजन सल्फाइड का। वो मेरे पास रिटर्न में साइन शुदा भी मौजूद है। मुझे बड़ा ही दुख हुआ है कि यार ये इतना। उन्होंने फिर 3-3 लाख रुपया उस जमाने में पर पर्सन पे किया और हाई कोर्ट ने उसे डिसीजन कर दिया कि टेक्निकल रिपोर्ट के मुताबिक इसका तल्लक ही जब कोई नहीं है तो इसके ऊपर कोई चार्जेस नहीं है। तो उन्होंने कहा जी हम चूंकि वहाँ पे पॉलिटिकल लोग हैं, हम इनको दे देते हैं, पैसे दे देते, पैसे दिए 15 लाख रुपया पे करके। और वो कहा कि हमने देखा नहीं, पहले वो हमें मुजरिम करार दे के भी हमने देने थे, पैसे दे दिए। तो इसलिए पॉलिटिकल इन्फ्लुएंस, ब्यूरोक्रेटिक इन्फ्लुएंस बहुत ज्यादा होता है। हम लोग कुछ नहीं कर सकते। आर्टिफिशियल रेन CM ने करवाई है, हमने उनको टेक्निकली फैसिलिटेट किया है। वी आर जस्ट फैसिलिटेटर। हमने यहाँ पर रिजेक्ट किया था, शाहीवाल पावर प्लांट लग गया। हमने इधर DHA में हमारे से जबरदस्ती इन्होंने DHA में रिकमेंड करवाया था, DHA के साथ वो BRB के बिल्कुल टच कि इसको आज ही रिकमेंड करो, सारे महकमे करो, और इतवार के दिन विजिट करवाया। लेकिन कोर्ट ने उसको, किसी ने उसको खत्म कराया। अदरवाइज हमारे में कहाँ जरूरत है कि हम स्टैंड करें किसी के साथ। इसके अलावा बहुत सारी ऐसी प्रॉब्लम्स हैं जो कि कहते हैं जी पॉलिटिकल विल हो ना वही काम होता है, पॉलिटिकल विल के बगैर कुछ नहीं होता। अब ये जो हम कजाकिस्तान में आर्टिफिशियल रेन जो करवाई है, बेसिकली बीइंग एनवायरमेंटलिस्ट मैं इसके खिलाफ हूँ, लेकिन हमने उन्होंने कहा जी मुंह बंद रखें जो हम करवा रहे हैं करें। तो वो कहते हैं जी डॉक्टर ने जब टीका लगाना है ना तो क्योरिंग के लिए कोई तकलीफ तो होनी है ना, थोड़ी बहुत तो हमें करनी पड़ेगी, थोड़ी बहुत कुर्बानी देनी पड़ेगी। इसके अंदर कार्बन डाइऑक्साइड इस्तेमाल होती है टेम्परेचर कम करने के लिए, कूलिंग इफेक्ट पैदा करने के लिए, कंडेंसेशन के लिए। उसके बाद सिल्वर ऑर्डाइड हैवी मेटल है वो नीचे आती है, वो हद से ज़्यादा जो ना आप इनहेल करते हैं। फिर उसके बाद साल्ट हैं जो कि हाइड्रोस्कोपिक हाइड्रोफिलिक हैं और वेरी रिएक्टिव हैं। उसके अंदर सोडियम क्लोराइड, पोटाशियम क्लोराइड, मैग्नीशियम क्लोराइड, कोई भी आप जो साल्ट हैं, ये जो अल्कलाइन साल्ट है इस्तेमाल कर लें, ये इसको कंडेंस करते हैं, सिल्वर आयोडाइड न्यूक्लियस फॉर्म करता है। बाहर के मुल्कों में सारे डिस्कार्ड हो चुके हैं, वहाँ पर वो मशरूम स्पोर करते हैं, वो उनके मशरूम उगते भी हैं और बारिश भी हो जाती है। अब ये ऑनिक कंडेंसेशन है, मैंने साइन किए हैं, ये देखें, इसने कुछ हीट पैदा करनी है, डिस्पर्स हो जाना है, किसने? स्मोक ने। आपने देखा होगा कि जब आप लाहौर आते हैं तो लाहौर से बाहर आपको धुंध का मसला है, क्योंकि आप चला नहीं सकते। जब शहर के अंदर होती है धुंध ऊपर चली जाती है, तो शहर के अंदर जिधर पोश एरिया है वहां धुंध का मसला होता है। शहर के अंदर ये लाखों करोड़ों रुपया बाद में लगेगा, हमने बाउंड होंगे उसको, और ये सिर्फ थोड़ी बहुत जो सर्दी हमने एंजॉय करनी है, ये लेटेंट हीट ऑफ कंडेंसेशन की वजह से ये भी सर्दी भी खत्म हो जाएगी और डिस्पर्स हो जाएगी। तो बहुत सारी चीजें हैं, हमें आला कार, इसको कहते हैं सहूलतकार बनना पड़ता है। हाँ जी, कोई भी सहूलतकार ऐसे नहीं बनता, उसके ऊपर कोई थ्रेट होता है या उसको कोई अपना खौफ होता है कोई किसी चीज का। तो इसलिए हमें उसकी भी जाहिर है कि वो हमें फ्री ऑफ करोड़ों रुपए के फ्री दे रहे हैं, कोई पैसा नहीं लगेगा। यानी कि पहले वो हमें दे रहे थे, सीधी सीधी बात है, वो पहले हमारे से मिलियंस रुपए ले रहे थे, उसको मैंने रिजेक्ट कर दिया। मैंने कहा नहीं लाना, ये इसका इतना फायदा नहीं है जितना हमारे, मेरे अलावा मेरे से बड़े लोगों ने भी इसको रिजेक्ट किया। उन्होंने कहा जी नहीं, हमने ईरान में भी लगाए हैं, कजाकिस्तान में भी लगाए हैं। हमारे सीएम साहब ने कहा जी बेशक अब फ्री भी दें, ये लफ्ज से हमें फ्री भी दें, फिर भी हम आपका चलता हुआ देख के साइन करेंगे। उस दौरान COP28 आ गया, मेरा विजिट था, मेरी सारी प्लानिंग हुई, इन्होंने पैसे भी मंजूर कर दिए, और डॉक्टर अरशद मेट्रोलॉजिस्ट एयरपोर्ट का मैंने और उन्होंने जाना था, एक बहाउद्दीन यूनिवर्सिटी के प्रोफेसर भी शामिल हो गए, फिर आर्मी का एक बंदा भी बाद में आया था, 4 हम लोग हो गए। तो ये COP28 की वजह से वहाँ स्मोक खत्म हो गई, तो उन्होंने फिर कहा कि अब वहाँ जाके क्या करना है। तो वो हमने बगैर देखे एग्रीमेंट साइन कर लिया है, पैसे कोई नहीं लगने, और ये है कि उन्होंने कहा कि हम आपको अगले साल बिल्कुल क्लियर स्काई लाहौर के ऊपर दिखाएंगे, और ये फिर आप बाउंड होंगे जब आप कहेंगे कि बिल्कुल ठीक है। जब आपने बिल्कुल ठीक कह दिया तो आप यू विल बी बाउंड टू साइन कमर्शियल एग्रीमेंट पेमेंट का फॉर अदर सिटीज। फिर हम बाउंड हैं, फिर हम बाकी शहरों में भी लगाएं। आर्मी भी इसके में इंटरेस्टेड है कि हमें स्मोक के लिए ट्रांसबाउंड्री या पॉइंट ऑफ एंट्रीज पे हमें कुछ नजर नहीं आता, तो हमने भी ये लगाने हैं। वो तो उनकी जरूरत है, ये वो मैनेज भी कर लेते हैं, लेकिन हमारे यहाँ इस सेक्टर में मैनेज होना बड़ा मुश्किल होता है।
सर मेरा क्वेश्चन था, सॉरी, लेटेंट हीट ऑफ कंडेंसेशन की आपने बात की, इससे तो ग्लोबल वार्मिंग बढ़ेगी जैसे आपने अभी बात की। दूसरा लेटेंट हीट ऑफ कंडेंसेशन जो आपने बात की,
ग्लोबल वार्मिंग सिर्फ यह है कि जो सूरज से जो हीट आती है वो 30% वापस जाना जरूरी है। ये छत जो बैरियर रोक लेती है, तो लेटेंट हीट की वजह से जो हीट बढ़नी है ना, वो इनका क्वेश्चन तो ठीक है, क्योंकि जो बेशक हीट सूरज से आए या हम लोकली तौर पे पैदा करें, तो वो ग्लोबल वार्मिंग का बायस तो बनना ही बनना है। तो मैं खुद भी इसके हक में नहीं हूँ कि सिटी के ऊपर तो फॉग ग्राउंड लेवल पे होती ही नहीं है, वो तो इतने चूल्हे, इतनी ट्रैफिक, इतनी फॉग अपर लेवल पे हमारी आई लेवल से ऊपर चली जाती है। हमें ऊपर से क्लियर स्काई क्या करना है? सिटी की एम्बियंस में स्मोक जो ना ग्राउंड लेवल पे होती है, पौधों की वजह से वो वहाँ पे जो एक्वेटिक होती हैं चीज़ें होती हैं उनकी वजह से वहाँ पे तो कोई नहीं होगा। हम जब मूव ही नहीं कर सकेंगे सिटी के बाद, तो हमने सिटी के अंदर करनी
सर,
क्या है।
दूसरा क्वेश्चन है कि आपने वो कंडेंसेशन पार्टिकल्स की बात की थी इंस्ट्रूमेंट से, तो वो कंडेंसेशन पार्टिकल्स का तो साइज बड़ा हो जाएगा, वो कंडेंस होकर नीचे आएंगे तो
नहीं,
वो
पहले यही था कि जब आयनिक कंडेंसेशन होनी है, अगर तो लेटेंट हीट ऑफ कंडेंसेशन खारिज ना हो तो दे विल श्योरली प्रेसिपिटेट, लेकिन ये डिस्पर्स होगा और ये ऊपर को जाएगा, क्योंकि टेम्परेचर जिधर ज्यादा हो ना वहाँ, इसीलिए धुआं ऊपर जाता है कि जिधर टेम्परेचर ज्यादा होता है वो कम की तरफ जाता है, ऊपर मूव करता है। यही टेक्नोलॉजी अगर हम पहाड़ों पे लगाएं जिधर ऊपर टेम्परेचर 0 है और ये पार्टिकल ऑफ हीट की वजह से ऊपर गए हैं, तो वहां पर ये प्रेसिपिटेशन शुरू हो जाती है। ये चाइना रेन हार्वेस्टिंग इसी टेक्नोलॉजी के जरिए कर देता है। लोकेशन मैटर करती है। अगर हम ग्राउंड लेवल पे करेंगे, लोअर लेवल तक इसकी अनेक इंडक्शन करेंगे, इसमें कोरोना प्लाज्मा डिस्चार्ज होता है जो कि डीसी हाई वोल्ट डीसी करंट से कोई चीज ऐड नहीं की जाएगी। ये इंड्यूस्ड पार्टिकल्स होंगे जो कि आम हवा से ही बनेंगे हाई वोल्टेज की वजह से। वो थोड़ी देर के बाद ग्रुपिंग करने के बाद फिर वो डिस्पर्स हो जाएंगे। ये उनकी मर्जी है कि अनेक कंडेंसेशन के बाद बारिश बरसाएं या डिस्पर्स हो जाएं। ये मैंडेटरी नहीं है कि वो बारिश बरसाएंगे।
सर, एक और क्वेश्चन है कि वेस्ट मटेरियल जो सॉलिड वेस्ट मटेरियल है उसमें प्लास्टिक पोल्यूशन का क्या कोई मेजर लिया है गवर्नमेंट ने कि नहीं?
देखिए, पहले इसके लिए भी बहुत लंबा चौड़ा एक है कि सबसे पहले आपने D2O बायोडिग्रेडेबल प्लास्टिक को बड़ा सुना होगा। फेडरल गवर्नमेंट ने बनाया और हमें भी ऑर्डर किया कि यही बनाओ। हमने कहा जी नहीं, ये इसके जो सनलाइट से ये पॉलीमर टूट जाते हैं। आपने देखा होगा कि जो वोवन एक बैग होता है वो सनलाइट में बुरबुरा हो जाता है। नहीं, सारे हो जाते हैं तकरीबन। ये उन कईयों की लाइफ होती है। ये अगर ये होता है जिनकी लाइफ 100 सालों से ज्यादा उस सूरत में है जब ये सूरज से दूर रहेंगे, जब ये बरी हो जाएंगे, जब ओपन में होंगे तो ये डीकम्पोज होने के बाद इनके फ्लफ जब हम इनहेल करेंगे हवा के जरिए तो हमारे लंग्स में जिंदगी भर के लिए ये चले जाएंगे। इसको कहते हैं माइक्रोप्लास्टिक। माइक्रोप्लास्टिक ये जो बोतलें आपने रखी हैं इसके अंदर भी होते हैं। ये जब माइक्रोवेव बेसिकली मैं आपको माइक्रोवेव घरों के अंदर जो है वो आपकी प्लेट को गर्म नहीं करेगा, सिर्फ पानी वाली चीजों को गर्म करेगा। उसके अंदर ऐसी इंफ्रारेड शुआएं निकलती हैं IR जो कि पानी से गुजर नहीं सकती, इसलिए वो सारी एनर्जी पानी के जरिए अपने अंदर छोड़ देते हैं और वो चीज या पानी हो या पानी में सोक्ड हो तो वो करती हैं। इसलिए इसके अंदर भी पॉलीमर को तोड़ने के लिए सूरज की छाएं काफी हैं। ये इसके अंदर हमें सूरज से बहुत सारी चीजें विजिबल, अब ये लाइट है इसके अंदर कुछ लाइट विजिबल है, कुछ इनविजिबल आ रही है। जो इनविजिबल लाइट है, जो UV है, वो इसके बांड तोड़ेंगी, IR नहीं तोड़ेंगी। इसलिए हमें कुछ भी दुनिया में जो भी एल्यूजन की वजह से नजर आ रहा है, जो भी मटेरियल है, अगर वो कंप्लीटली अब्जॉर्ब कर रहा है लाइट, काला नजर आएगा। कंप्लीटली अगर रिफ्लेक्ट कर रहा है वाइट नजर आएगा। अगर पौधा कोई भी ग्रीन नहीं है, पौधे जो अनवांटेड वेवलेंथ है, ग्रीन अनवांटेड वेवलेंथ है, हम उनको ग्रीन की वजह से लाभ करते हैं, वो हमें ग्रीन पसंद ही नहीं करते। तो इसलिए हर मटेरियल, मेरे ये जो रंग नजर आ रहे हैं ये सारे के सारे ऐसे पिगमेंट हैं जो नीला पिगमेंट रिफ्लेक्ट करते हैं, बाकी को ऑब्जर्व करते हैं, इसलिए नीला नजर आता है। एक्चुअल किसी का भी रंग अपना नहीं है, ये रिफ्लेक्टेड लाइट की वजह से नजर आता है। जब मैं टाउन हॉल में था तो मेरे पास GC यूनिवर्सिटी और ये बहुत सारे उकाड़ा यूनिवर्सिटी बेशुमार लोग इंटर्नशिप करते थे। मैंने बहुत सारे थीसिस भी करवाए हैं। अगर आपने इंटर्नशिप करनी है तो EPD पंजाब में जाके एक एप्लीकेशन दें, इधर से आपके HOD की तरफ से रिकमेंडेशन होनी चाहिए। तो इनहेरिटेड प्रॉपर्टीज होती हैं, मेरा बेटा भी वहाँ पे वो बड़ा ही सपोर्टिंग है, तो वो एनवायरमेंटल इम्पैक्ट असेसमेंट सेक्शन में EIA सेक्शन में है, वो उसमें हमारे जो हैं EDH है, हैजर्डस वेस्ट मैनेजमेंट, EIA एनवायरमेंटल इम्पैक्ट असेसमेंट, बस लीगल सेक्शन है, उसके बाद डेंगी है। ये जितने भी हैं आपको ना वो बांट के लड़कों या लड़कियों को डिस्ट्रीब्यूट कर देते हैं। फिर वो कहते हैं कि आप 3 महीने के लिए आए हैं, आप हर सेक्शन में 1-1 महीना गुजारेंगे। वहाँ पे बड़ी अच्छी आप उनकी प्रैक्टिकल आपका जो होगा तो वो अच्छा नॉलेज लेके आएंगे।
थैंक यू सर।
थैंक यू।
Thank you, Dr. Muhammad Yunus Sahid, for sharing your experience. I will request Dr. Syed Abdul Rahman Kashif to present souvenir to Dr. Muhammad Yunus Sahid.
मैं आगे आपकी आपको बहुत खुश हुआ। ये इस बोतल को बनाने में, प्रिंटिंग करने में, पानी की लिए पावर प्लांट चलाने में पीछे फॉसल फ्यूल की लगता है, बिजली से सारी चीजें चलती हैं। इसलिए हमारा कार्बन फुटप्रिंट फिर बने हैं हमारी लाइफस्टाइल के हम सिंगल यूज प्लास्टिक है। एक बंदा खाना खाता है, कितना गंदा, कितनी जो ना वो प्लास्टिक की बोतलें जाया होती हैं, फिर हमारी कार्बन कंट्रीब्यूशन पर पर्सन बढ़ दिया। हम बेशुमार कुछ चीजें करते हैं जिसका हमें पता ही नहीं है कि हम क्या देखिए 85% पोल्यूशन आपको एक रिसर्च ने बताई है। 84% जो ना वो पेशावर में, 85% सिर्फ आप लोग गाड़ियां इस्तेमाल करते हैं, मोटरसाइकिल इस्तेमाल करते हैं, बायोफ्यूल गैस इस्तेमाल करते हैं, बिजली जाया करते हैं। या बिजली जाया करते हैं तो उसके पीछे एक फॉसल फ्यूल फायर्ड, कोल फायर्ड पावर प्लांट चलता है। ये कार्बन फुटप्रिंट है। ये नहीं है कि आप कार्बन डाइऑक्साइड यहाँ बैठे इमिट करते हैं। आपकी एक्टिविटी से, आपकी सोशल एफर्ट से कोई सी एनवायरमेंट को नुकसान पहुंचता है, जो व्यक्तिगत में कार्बन डाइऑक्साइड होती है, वो आपकी कार्बन फुटप्रिंट है।
प्लास्टिक बैग बनाते हैं, ठीक है, आप उधर तो कह देते हो बड़े बड़े प्लास्टिक वाले बड़े माल जो है वो बंद कर देते हैं, लेकिन जो रेडी आपकी 80% दूध दही और घर सब्जियां बिक रही है, तो हम क्यों नहीं रिप्लेसमेंट की तरफ जा रहे हैं? सर मैं एक क्वेश्चन मेरा ये है कि वो जो प्लास्टिक बैग है सारे वो जहाँ बनते हैं यूके वगैरह है, जो आपको इम्प्लॉयमेंट करने के उन्हें बैग करके रिप्लेस करें, तो बेसिकली उनको दूसरे लोग बेचने तो ना, हम यहाँ पे लोग बढ़िया लगा देते हैं कि ना प्लास्टिक बैग जो है उसका इस्तेमाल हो रहा है, क्योंकि ये
इसका बात मैन्युफैक्चरिंग हमको नहीं है। जैसे अल्लाह ताला ने कुरान छुड़ा हुआ है, हमें कहा हुआ है इसकी बात नहीं मानी, हमने मैन्युफैक्चरर को हटा दिया हुआ है और इस गलत करते हैं कि प्लास्टिक का इस्तेमाल ममनू है। हमारे इस्लाम में प्लास्टिक का 10 माइक्रोन से बड़ी ममनू है, सारा ममनू है, जबकि हमारे अब सिंगल यूज प्लास्टिक में ये सारी चीजें पॉलीस्टाइरीन के सारे हमारे पास स्मोक से अब हमने गर्दन खाई है। अब हम इसको करेंगे, पहले 20,000 का जुर्माना किसी भी प्लास्टिक बैग के स्टोर को जो होता है कि आप शॉप बैग बात करें, अपनी जगह पे नाम मोहम्मद पीपी का बैग है, वो प्लास्टिक है। आप जो दूसरा नाम हो
प्लास्टिक यूज जा रहे हैं, यही तो मेन क्वेश्चन है कि हम जो है
इस कारण नहीं है। अगर आप पेपर बैग में तरबूज लेके के जब बारिश हो गई तो तरबूज नीचे आ जाएगा, आप फिर उसको
हम बर्तन में लेके आते थे, डोल में हम बुनते लेके आते थे, कपड़े में